it's kind of just become an incidental tradition that I just go, you know, weird rhythmic shit on the intro. With the whole... I think it's...
You were not streaming.
There it is.
Oh,
there it
I
is.
see something.
Yay! We are live! It is live time with the Ari!
Holy shit.
What's that?
You know what? I'm gonna let them know. I'm gonna let my server people know that I'm going to put your ass.
Please do. Please lead me down all the wrong holes. And fucking stress test me.
Right.
Anyway, so hi, welcome to the stream. It's peer programming time with Ari. Oh, I should actually fucking add you to the fucking video title. Holy shit, I'm an asshole. Ha! Oh my god, everything's a failure. Anyways, yes, hi. Let's see, with at Ari. It's so weird because like if I start like if I do the at to like tag you, right?
Yeah.
It like it will show you as like the second result because like we've done like collaborations, whatever you want to call them, like semi recently, right? But then if I type out Ari, it's like, oh, I don't know who the fuck that is. It's so strange.
Yeah, I don't quite get it.
I don't know.
It's like, but it's not like there's a whole bunch of it. It's like there's no other art. Yeah, I don't get it.
It's a strange, wonderful world. Anyways, I'm gonna very quickly yank your server and site because I'm guessing you want those linked. Yeah. So for those who are interested in Ari shit, okay, it has now been added to the description. Yeah, it might be delayed, but I'm trying not to be an asshole.
Yeah, I can give you my website or my server if you want. Although I think
I threw them both in the description. Give it a quick refresh, and then I think we can slam into it after that. Should be there. I see it.
Yeah, I just copied it. Yep.
Cool. Awesome. Yeah, I just yanked it from your little Discord profile thingy.
Perfecto.
Hell yeah. Anyways, yeah. So okay. to give context for anybody watching this now is the long story short is so I want to get into the whole programming world. Wonderful gobbledygook, right? Long term, I have an interest in game as every fucking idiot does. So as far as my knowledge goes, Vulkan is a very important step to that, and Vulkan is effectively the semi-universal API for accessing like the GPU, right? It's not like the like absolute stupid shit like hot wiring your car to go slightly faster and adjusting the tunings live, like that insane shit, but like it's like the 99.9% of the way there, right? Like realistically it's going to be about as good as it's going to get for a newbie like me to like access a GPU, right? And whereas
normally we kind of like have like most like programmers start like with OpenGL when they kind of like start with the graphics programming, so this is going to be like extra fun for you.
Yeah. So to preface that, the reason why I don't want to learn OpenGL first is simply because like I don't really want to learn two things, right? Like throw me into the deep end, fuck it, I'll learn to swim, right? The second thing is because of the space that I tend to lean into, I actually have a harder time with larger abstractions, right? So when it comes to something along the lines such as OpenGL, I actually fear despite OpenGL being easier, it'll be harder because I'll understand less of like the problem space, right? It's kind of one of those weird like inverted fuck you problems with me, right? And yeah, so I guess to anybody watching this, the sort of context for me is I have done some very light C++ programming. So I basically made a few CLI tool stuff, right? For example, I'm taking some math classes with my college stuff right now, and I've made like terminal programs, right? So it's like just simple stuff like quadratic, like a quadratic formula thing where you throw in your ABC and then bam, right? So like understand that. I've never had to use pointers or addresses before, like in those programs, outside of like the initial like args and whatever, right? I forget the exact context of it, but yeah. But I do understand like them in concept, just not in like practicality, right? I surprisingly, I think I know more about how a CPU actually runs than how the other stuff actually works. So that's very fun. You love writing shaders? Heck yeah. You take math classes and they're not working because you don't know basic algebra. Rude. I also don't think I said they don't work. They do work. In fact, actually, here's a funny little side thing. So I have like a programmable TI-80 whatever the fuck, right? And it was actually very fun because I had this really fucking bad time where I was trying to look up like a quadratic formula like thing to throw on the TI whatever, right? TI-84, I mean, it's probably TI-84. I just bought off of the Facebook Marketplace. I just know it's programmable. That was my concern, right? And, long story short, I downloaded like 3 quadratic formulas from like quadratic solvers from like a fucking from like a TI-84 source code repository, right? All of them were wrong. Because I know how to do it, right? I just wanted it to be faster, right? I shit you not. 3 different programs that were like highly rated were just wrong. And it's just like,
I mean, I don't even know what's like more disappointing. The fact that you resorted to using those programs because you couldn't just do the fucking progression, or the fact that the fucking software that's dedicated to doing all of them were fucking wrong. I don't know which I should be more disappointed at.
Well, okay, so like with mine isn't the Python version, right? So it wants you to learn like the XA7 or XA8, whatever the like TI-84 source code assembly basically is, right? Like whatever that is. And like the thing is like I don't mind learning that, but like in reality, like I don't want to learn like a bespoke like weird thing, right? My intention is basically I'm just gonna go like I'll just go get like the Python one later because I at least care about learning Python, right? So I was like, whatever, I'll throw this on here, get the math test done, and then move on, right? Because, like, I have other things that I want to study before the fucking math test, right? It was literally just meant to be an accelerant of, like, saving, like, the 15 steps of having to, work through it, right? Not 15 steps, it's like 3, but you get the idea, right?
Yeah.
And yeah, it's like, I don't lack the capabilities, I just wanted the accelerant of it, right? And it just, again, was wrong. I'm like, why? There's no reason for this. It's really a handheld Z80 computer. Yeah, no, like I'm aware of that, right? And like I looked into it. It genuinely seems cool. It's just that, like, under the constraints, I didn't have the time to, like, learn to write the program, right? Oh, and another fun thing, too, and this is one reason why I'm, like, not exactly pro AI. I literally asked 3 different AIs. It was like GPT, Claude, and R1. I asked them all just like, hey, write me a quick quadratic solver, right? Because like again, I just didn't like I was just like, yeah, I have like half an hour before I need to sleep. I'm not learning how to do this in half an hour, right? And again, all of them were wrong. So I went to 6 different sources, and nothing can give me a quadratic solver. And it's just like, fucking what?
Hey, what are you doing? What are you doing? Now is not the time for attention, mister.
But yeah, anyways.
Oh, you got Doggo.
Yeah, Doggo is just like sitting here being a little needy nerd, and it's just like, what the heck's going on with you, dude? Let me throw him a quick bowl of food, because I think he's just being an absolute wonderful glub like that, and then we'll see what's going on. Oh, okay. Okay, here's your food, fat dog. Okay. Okay, there you go. Okay.
If you want anything else, I'm gonna bunt you.
Okay, anyways, yeah. So, where am I going with this? So, yeah, so now with where we're going, yeah, so the TLDR is, I think it's in, chapter 3 is where you get the magical Dorito of Doom, somewhere in here. Anyways,
Yep.
I think it's in the Legacy V1 guide, shows the good one, like here, drawing meshes, no. It was one like before that, draw, hello triangle, there we are. The goal is to get to here. If we can get to here today with that legendary fucking cornflower blue or whatever it is, that's my win condition, right? Yeah, here we are. And then Ari over here is a much smarter person than me when it comes to this shit. Yeah, he's here to bully me and judge me and make me feel bad. And
Perfect.
yeah, call me an idiot and all that other wonderful fun stuff, right? This is going to be a similar format to the C manual for those of you who remember that. So that's either great or terrible depending on who you are. And then suffering. Also, I would like to do. I have to acknowledge I have the small weenus energy right now. The dried up scratchy weenus energy. I have to use Visual Studio Code right now. I couldn't get NVim working before the stream because I forgot how to configure. Pardon, sorry?
How dare you use a fucking text editor outside of Notepad?
I mean, honestly, you want to? I can use Kate. That's basically... No. We can use Kate. Stupid. We can use Kate. It's right here.
Fucking stupid, dude.
It's right here. Oh my god. Just make life, like, extra painful.
Fucking Kate.
Honestly, have you tried Kate for, like, a hot minute? Like for more than 20 seconds?
It's pretty good.
Right? Like, it's actually just fucking solid. Like, I'm genuinely surprised because, like, I forget what it was, but I think I was doing, like, some playing around on, like, I was playing around for 5 minutes with trying to get my, my, like, Raspberry Pi, like, Pico to, like, talk over the internet, right? Or something like that, right? And, like, when playing around with it and, like, searching shit, I found out it had an operating system that could run on it, right? It's a very stripped down version, but, like, sorry, there's an operating system that can run a GUI, right? So I was like, holy shit, I gotta see this. And it fucking chugged, to be very clear, right? But yeah, I played with Kate on it for 5 minutes, and it somehow ran. Barely, but it did. Yeah, anyways, I should probably stop rambling so much and actually fucking get onto this. So, yeah. I mean, hey, Ari, I guess this will give you time to fucking edit your video while I'm rambling with all these fucking paragraphs, so that's fun.
Oh, yeah.
Yeah, I don't know. I've been doing a lot of yapping. Anything you want to add, Ari? Anything worth pointing out?
Nope. Let's throw your ass into this.
Okay, cool. I'm gonna make sure I'm on the introduction because there's been many times where it isn't the thing. So yeah. So Vulkan. Where's Vulkan? Vulkan is a fucked up line 1. That is fucking beautiful for how the stream is gonna go. Vulkan is a cross-platform graphics API application program interface developed by Kronos Group. The Kronos Group. The Vulkan API is a standard, therefore it can be implemented on multiple devices, platforms, and a variety of different programming languages. Vulkan is designed to be used in high-performance multi-threaded applications. Vulkan especially benefits from its design, and it is more explicit, reducing the guesswork performed by the graphics driver. Using Vulkan correctly yields high performance, low latency, and consistent frame times. Yeah, there's the TLDR. Overview of the Vulkan API. The Vulkan API provides a list of functions, what arguments to pass in, and the return type. The API is written in the C programming language and should be compatible with vast majority of languages. Although this tutorial is written in C++, porting it to other low-level languages such as Rust or even plain C should be straightforward. Honestly, I've never had an issue converting C++ to C code and vice versa. If you understand C, it should be brain dead to do vice versa. I shudder to think of the people who can't. I mean, like, I know, like...
If you kind of struggle with that, you really probably should not be touching Vulkan then.
Right?
Or just computer graphics in general, because that shit's, like... That shit gets pretty nasty.
Yeah, like, doesn't, like, C++, like, I could be wrong, but doesn't C++ only... Or not C++, but, like, C only have, like, 16 keywords or something? Like, something incredibly simple? Like...
I think it's, like, closer to, like... 30, but yeah, a lot of the basic structures that y'all probably kind of like rely on, like maps, hash maps, vectors, and mutable like kind of data, like that we all kind of take for granted. There's fucking none of that.
Yeah. You
pretty much have to build all that from scratch if you want to use C, which I hope the fuck you ain't doing that. Unless you're like embedded.
You want to know something actually probably that you'll either like or absolutely hate about me?
Oh god, what?
I like only use boomer loops. Like for int I equals 0, you know, condition increment. I like only use those. Like
as opposed to like for each loops or
yeah, like for each, do whiles, all those other variations, right? Or like you'll see like you know like for each, you know, variable in array dot map, and then you know like you know do the iterations, right? I never use any of those. I am a boomer looper for life.
What the fuck?
Well, okay. The TLDR for me is that the syntax is always one of those things where it's like, oh, is this an arrow function or is this a dot, like, you know, separator, right, and all these other things, right? So I always get garbled up with the syntax, and by the time I go away, look up the syntax, come back. I could have done just for like object dot keys, array or map or whatever, right? Object, whatever you want to call them, and then do thing, right? I find I waste so much more time trying to remember all like the magical like syntaxy stuff instead of just doing the for and then the loop condition. I don't know. It's a weird thing. It's just every other loop I have issues with. It's thrilling. Anyways, cross-platform. Vulkan's design is unique compared to other graphics APIs because it offers the same API for both mobile and desktop. This means that many features in Vulkan are optional, and using them requires explicitly turning them on. It is common to have these features that are unsupported on mobile but supported on most desktop GPUs. This is a great question because this is my first interjection, I guess, with the article. Is if something is not available on like a platform like mobile that you're trying to compile to, does it just like error out? Like, does it just say like not available, or like does it try to like smartly convert it over, or is it like some magical mix of both?
So it kind of depends on like the application and how far you kind of got to go in. But if you're talking about like enabling a feature or an extension on like an instance or a device, and your like mobile GPU, for example, like on your smartphone, for example, can support like whatever you're trying to support, it will actually give you an error just saying a feature that you're requesting is not supported.
Fair enough. Yeah, because I know compilers do some magic. Like I know there's actually a surprising amount of ARM chips that actually don't have like a multiplication or division circuit, right? They just have like an addition or subtraction, and you just have to deal with that as the end user, right? But most compilers I know will like kind of like magically just convert multiplication and division to that, because that's what it is, right? Yeah, just curious. Let's see now. Where the fuck were we? Because I scrolled a little bit. The mobile market has a problem with fragmentation. Not every phone implements Vulkan, especially older phones, and a lot of those that do, you may have problems with driver quality. The phones with good drivers for Vulkan especially benefit from the lower CPU overhead and often see less extensive performance boosts. While, holy shit, I could not read this sentence. My dyslexia there. Holy fuck. Fucking every word. I was like, the period's right here. No, it isn't. The phones with good drivers for Vulkans especially benefit from lower CPU overhead and often see extensive performance boosts, all while using less battery. Holy shit, I don't know why I struggle with that sentence so much. Fuck. That makes a lot of sense. My guess is like BlackBerry is probably one of the worst ones if I had to guess, if they're still not using Android. I could see that being a pain in the ass. Cross-platform. Vulkan's unique design compared to other graphics APIs. Sorry. Didn't we just read this part? Oh yeah, no, we read that part already. What the fuck am I reading? Let's see. Yeah. No. What? Sorry. Okay, this is okay. Anyways, let's see. When you use Vulkan, if your main bottleneck is GPU side, it is unlikely that implementing Vulkan will improve your performance enough to be worth it. It should be mentioned that Vulkan is significantly harder compared to OpenGL, and its extra complexity often means longer development times. If your application consists of big maps, dynamic worlds, or CAD-type scenes with a lot of objects, then Vulkan's multi-threaded capabilities will likely boost performance. Yeah, sorry. If your main bottleneck is on the GPU side, I don't know why mentally I mapped that as like not on the GPU. I'm like, what the fuck is Vulkan for? Let's see. There we are. Okay, yeah. I should just start highlighting like the start of where I was. Let's see. The mobile market has a problem with fragmentation. No, I just read that. What the fuck? Oh, I know what's happening. Sorry, my mouse does a thing where on the scroll it'll sometimes double scroll, and then it just freaks out. Yeah, that's okay. That's what's messing me up. Okay, yeah. Okay. Let's see. When running Vulkan powered applications, yeah. Okay, there we go. When running a Vulkan powered application on both desktop and mobile, you have the options of using one or two core render paths. It is recommended that to run 2 core render paths as an alternative. It is recommended to run 2 core render passes in the alternative, as the alternative will be at best. Oh my god, why can I not read right now? Why can I not read it? Oh.
Do you need me to read it?
Daddy Ari, can you help?
Holy shit. No, okay.
It is recommended to run 2 core render path, as the alternative will be at the cost of a suboptimal performance. The API being unified means the 2 render paths can actually share code in between them.
Thank you. Oh my god, I don't know what it is, right? It's just one of those things where, like, I think I'm trying to just go too fast or something and like spam through it, because, like, oh my god, it was like, I don't know. I feel like I wasn't doing that bad with the C manual by compare. I don't know, man. I hate myself. This tutorial will be focused on writing Vulkan for desktop. However, we will cover many of the differences between the 2 types of GPUs. Validation layers. The Vulkan API is vast, and as a result, it is easy to make mistakes. But this is where validation layers comes to the rescue. Validation layers is an optional feature in Vulkan that detects and reports incorrect usage of the API. Validation layers works by implementing your function calls and performs a validation on the data. If all data is correctly validated, a call to the driver will be performed. It should be noted that intercepting functions and running validation comes with performance loss. I don't see a world where that would not happen.
I really hope that's like obvious, but
yeah, this
like,
may surprise you.
Intercepting the function to validate the data before you actually call it. I really hope someone would figure out that it's actually like maybe not as optimal, which is why you don't fucking turn that shit on and release.
Yeah, crazy that, right? God, I actually a side just like minor tiny thing with that is like a thing that I've low-key been like really like digging using is so on my website, if you dig through some pages where I do more testing, right? I actually have like asserts implemented, right? But they're like for testing, and what I actually do as like a cheap way to ignore the asserts, because like, you know, like when you send that shit to the user, it's like, you know, like 8 kilobytes, right? Like if that, once it's all been like compressed and gzipped and whatever, right? But anyways, so it's very funny because what I do as a cheat to check if I'm in dev or not is I literally just look at the URL of the page. If it's like 127 dot whatever, then I enable or disable the asserts based on that. It's the most hacky thing I've done. Oh god. The silence speaks words. Let's see. Let's see. Didn't we read that already? This should not be using this one. No. Oh no. Yeah. Okay, we just read that. The validation layers are useful catching errors such as incorrect configurations, using wrong enum, synchronization issues, and object lifetimes. It is recommended to enable Vulkan layers while developing to ensure that your code follows the specification requirements. Running your application without any reported validation errors is a good sign. However, it should not be used as an indicator for how well your application will run on different hardware. We recommend you test your application on as many different devices as possible. We all know 100% code coverage means that your code is flawless, right? Millie. You good, Ventura? You having a good time? Having fun? I'm gonna assume Ari died because they are very quiet right now for some reason.
I was just trying to listen to this. It's like, I just don't want to.
Oh no, fair enough.
I just don't want to root it.
No, fair enough. But yeah, no, freaking yeah, no, the 100% code coverage thing. That's always worked, right, Ari?
Yeah, that seems a bit important. What kind of pizza did you get, Ventura?
Oh, yeah, we will judge you heavily, Ventura, for this. There is wrong answers. I just want you to know that. So what was it? Share.
What is it gonna be?
Share. Plus new mic term. Well, I mean, hey, heck yeah.
Hey.
Have fun with your VA adventures, Ventura. They're attempting to do that. So, best of luck. I guess I'll read this until Ventura sends what pizza it was. It's important to note that the validation layers does not catch bugs like uninitialized memory and bad pointers. It is highly recommended to use tools such as Address Sanitizer and Valgrid. Be aware that graphic drivers often create false positives when using these tools, making their output quite noisy. Okay, what the fuck is either of those? Address.
Valgrind is a memory management tool that you can pretty much like execute your program like off of Valgrind directly.
Okay.
And what it will do is it will actually keep track of all the memory allocations and frees that you do, and it will actually tell you where you've accidentally not free data when you should have. So it's like a resource leaker, and also like check some other things like that gosh. Yeah, you should have it on Linux, but if not, you can just fucking install it.
Yeah, I'll
in the
probably
terminal.
ignore these for this because I don't see myself needing to use it for this. One thing I actually want to look into more for like larger programs is, I'm guessing you know this, but like arenas. Like, are you aware of those? Oodles Ventura, you did not answer the pizza. You did not answer the pizza. Anyways,
They were just pleading the fifth.
Yeah,
They
I
made a
suppose
bad
so.
choice.
We know you like anchovies and basil pizza. Anyways, but yeah, no. So what was I gonna say? So like, I'm not gonna worry about any of those validation tools for now because I think right now they'll just muddy the waters and be hella distracting, right? But I do think I'll look into those later. Another thing that I actually.
The validation layers, I'm gonna have you like turn those on because it's like a couple of clicks.
Oh, validation layers, totally. If it's a couple of clicks, then like hell yeah. I don't know what the
Like
hell.
if you've installed like the Vulkan SDK and all that, and you like run vkconfig, which I will fucking do
Hell yeah.
for you, but yeah, I can give you the settings that I use.
Yeah, totally. So, yeah, fucking, I think we outlined this in the premise. Maybe I explained it poorly, but yeah, for those of you who are unaware, I'm gonna attempt to follow the tutorial, and if I get hopelessly lost, then Ari's the safety net. I am the stupid child playing on top of the like 3-story like playground, right? And like Ari's the like concerned dad watching from below. Hell yeah. Hey, Donovan Roberts. If you want I'm gonna say Donovan. I'm guessing is what you'd prefer. How's it going? It's Ned. Hello, Ned. It is nerd shit time over here on the stream. Let's see. I mean, like, hey, let's roll on while they reply. Let's see. In the Vulkan API, almost everything is designed around objects that you create manually and then use. This is not only for the actual GPU resources, such as images and textures, but buffers for memory and things like vertex data. But a lot of internal configuration structures. For example, things like GPU fixed function, like rasterizer mode, holy shit, are stored in pipeline object, which holds shaders and other configurations. In OpenGL and DirectX 11, this is calculated, quote, on the fly, unquote. While rendering, period. When you use Vulkan, you need to think of it of its worth to the cache these objects or create them while rendering on the fly. Some objects like pipelines are expensive to create, so it's best to create them on load screens or background threads. Other objects are cheaper to create, such as director sets, and it's fine to create them when you need them during rendering. Figured to hop in since you're playing COD and hang out. I mean, yeah, feel free. This is going to be a very boring stream. This is easily one of my more nerdy streams. Probably my most nerdy stream.
Yeah, I
actually.
expect Mobile to just kind of struggle like badly.
Oh yeah,
Just trying to figure all this shit out. You're in for a fucking treat. Don't worry.
If I struggle to do a children's coloring book, do you think I'm gonna have this shit at all? I'm fucked.
No, don't tell me you actually.
No, I don't. It's just for the gaff, but like.
Oh, thank God. Thank fucking God. I got scared for damn.
Shit, what number is 3 again? Yeah, anyways, fuck. Let's see. Because everything in Vulkan is pre-built by default, it means that most of the stable validation on the GPU will be done when you create the object, and the rendering itself does less work and is faster. Good understanding of how these objects are created will allow you to control everything executes in a way that will make the frame rate smooth. When doing actual GPU commands, all the work on the GPU has to be recorded in the command buffer and submitted to a queue. You first allocate a command buffer, start encoding things on it, and then you execute it by adding it to the queue. When you submit to a command buffer in a queue, you will start executing on the GPU side. You have tools to control when that execution has finished, if you have submitted multiple commands in different queues, it is possible that they execute in parallel. I was expecting a different sentence structure there, so my brain went all gurgly. So here's actually a question then. So, does the GPU, obviously the drivers for like a GPU are like, you know, like, I'm gonna go hyper abstract and just say like a mini OS, right? So like, how much of that code is like running on the GPU, where like on like is it like almost to a degree like RAM, where it's like you're basically hard accessing everything, or is it surprisingly abstracted from the GPU?
It's a little bit. So you do kind of like make your own like memory allocation calls and all of that. So you do kind of like directly write into memory that would be represented in like device local, or essentially like the GPU's VRAM. And you do kind of make like commands saying it's like, hey, you want to bind this pipeline, you want to like load these buffers in as like vertices, and like the kind of stuff that you might like see in like OpenGL in terms of like the execution and all of that. But there's a lot of it that is kind of like about as close to the GPU as you can without like assembly.
Fair enough.
Like understanding GPU assembly.
Yeah, because the wording here with the command buffers and the queues, I wasn't sure if those queues were effectively abstracted, similar to like okay, so like
they're abstract. So they're kind of like the mailboxes that you kind of like put in all of the command buffers. Those are kind of like the little like pieces of information that you use to actually write down what you want the GPU to do, and then you collect a whole bunch of those, and then you create a submit information, which is to say, hey, here's the command buffers that I want you to do. Here's in the order that you should start them, and like if this is done, here's like all the like little bits and pieces that you want to signal. So any other kind of like graphic stuff is like you want to like tell us like, hey, we're done, you can do this now.
Definitely.
And then you push all of that into the queue, and that's kind of like a little mailbox structure that you want to like send all that shit to.
So one more thing too that I actually do have to that I am actually curious with now is, so I understand anything with IO is effectively async, right? And although you can make estimations for return times, it isn't that reliable. Is most of like GPU programming effectively like you make a call to the GPU and then wait until it's done, like with like frames as an example, or would it mostly be like you do something on like the CPU thread, you do some other stuff for a bit, and then when the GPU returns, then you like build the frame?
Yes and no. So you can actually like send all your commands and then explicitly wait. And then what you can do is like while you are waiting, you can actually like have that same thread actually do other stuff and then come back.
Yeah.
And check again.
Yeah, because I know JavaScript does something very similar to that with the whole like async and stuff like that, right? Because I know like JavaScript is debatably the most optimized single-threaded language, right? Or like garbage collected language, I should say. Single-threaded garbage collected language. There we go. But like, so like, yeah, no, it's like somewhat interesting to think about, because like as a jamer, like before getting into programming, I always had the blind assumption that effectively what happened was basically you sent all the data to the GPU did like more or less all of the crunching and then returned, right? And it's like, with going into this, it was one of those things where, like, I've never had the assumption challenged, and it's like, oh yeah, wait a minute, those assumptions are fucking stupid. They make no sense.
I mean, with some like GPU driven development, you could have like more of the stuff that's normally like you could do on the CPU, but you can move it on to the GPU. Like a lot of the physics stuff and the collisions and like do all of that is like you could do it all through the GPU, but like a lot of like the main control stuff and the fact that you have, probably stuff that you want to like multitask at the same time. That's why I kind of like say it's a yes and no.
Yeah, no, totally. Yeah, because like as far as my mental image goes, effectively what GPU development would be ideal for is anything that is not critically synchronous, right? So like you know, like this is obviously the most easy example, like physics, right? Like if a physics calculation returns late, it doesn't really matter like that much, right? Whereas, you know, like something like math steps, you know, like ABC, right? You know, if B returns after C, that's just a whole fucking issue, right? So yeah, I don't know. I probably explained that poorly, but hopefully it works out.
So to deal with that kind of issue is that we do have what we call semaphores and fences, to where you can actually ensure that a process can only finish or specifically start after a specific like little thing has finished. So the structure that you want to look up is called VK semaphore.
Semaphore. VK semaphore 3. I will add this to the pin because that looks like a whole ass read.
Oh, dude,
it's like
every single thing about this is going to be a badass read. Don't worry about
it. just like, yeah, so imagine the Bible, times it by 100, and then go fuck yourself.
Pretty much like trying to go through the whole spec. Like the text is probably like 2 time zones big. Don't worry about it.
Yeah, no. So hold on one second. Vulkan spec. I wanna like look this up for people who don't know.
Oh yeah, do the Vulkan spec and then all the exceptions. Yep, with all registered extensions.
Yeah. So
you can change the .html to .pdf, and that should probably give you like a better estimation up at the top of the URL.
Oh fuck! Sorry, I'm so used to macOS where the super key is like non-existent.
Got you.
There we go. Because I'm very like hotkey focused, right? So I went to hit like Command L and it was like, holy shit. Let's see. Let's do the oh my god PDF. There we go. So yeah. So. All right. You know, let's just do this. Vulkan spec PDF. There we are. Boink. So for anybody not aware of what Ari's talking about, right here is the best example. For those of you who cannot see the number because rendering or whatever, 5,844 pages. And as far as I'm aware, no, most of it is not graphs. Actually, yeah, here's a great example. Moving my mouse like a pixel jumps at 1020 frames. Like literally the smallest increment I can move jumps at 6 pages. Like, oh.
You said 5,844
pages.
pages?
Yeah.
So that is 1.632 kilometers if you lay every page like lengthwise end to end.
Hell yeah. Hold on. I want to see if there's a printed version. You know somebody's had to do it, right? Oh, God. Can I be the first? Wait, hold on, wait. Staples, printer paper. I just want to do this for a second. So, okay.
Yeah, are you trying to calculate just how much it would fucking cost?
500 pages right here, right? So, I'm going to say $9. Oh, we got 5,000 sheets right here. We could do it for a little over $90.
Now you gotta get the fucking ink.
I think the ink...
No, wait, you need a laser printer. You can...
I think the ink would unironically bankrupt me.
Oh, dude, yeah.
Oh, no, that's funny, though, actually. Imagine... You know what the worst part is too? Is that, like... You know, like, before you even reach page 100, the spec is probably outdated that you're printing.
Yep.
Yeah.
I think it changes, like, every couple weeks, too, so...
Yeah. Oh, shit. Super random side thing is are you aware of, like, the Vulkan 1.4 implementation race?
I think so, yeah.
Yeah, so for those of you who are unaware, just long story short is like when Vulkan 1.4 like was released, it was basically formalizing, I think it was like 8K support or something like that, right? Basically like everybody like that like would care was like racing to have like their updated driver out. It was legitimately like everybody updated within like a week. It was shocking. And that's what
because originally with 1.3 the guaranteed minimum image size that your GPU would just needs to support was 4K. But with 1.4, yeah, you're like what you said, that got improved to 8K.
Which, like, let's also be real. There's basically not a GPU that is still being used that can't support 8K. Or can't use 8K.
Yeah. My application literally requires like you to support 16K for images.
Yeah, that's...
Actually, let me show you a website.
Ooh. I'm missing your link.
Yeah.
Cool. I'm gonna hide this.
I forgot I can't do it in the chat. So let me fucking DM you this. Oh fuck.
I'm gonna hide the screen share for 2 seconds just because I'm gonna open Discord on stream, and then I'll re-enable in just a second. So what Vulkan is, Megacat, is long story short, is it's effectively a mini programming language that people use to implement GPU support and stuff, right? That is...
So if you've ever heard of like OpenGL or DirectX, it's pretty much like a programming interface that game developers and engine programmers can actually use to have your graphics card run computer graphics, like draw up your meshes, your models, the scenery, the lighting, and all of that. And it's just a lower level like variation of like what most programmers are used to doing. And Vulkan's trying to, Volbyte's trying to go fucking balls deep. Just
now do it stupider.
No. Yep.
Yeah.
It's fucking gorgeous.
Yeah. Yeah. Sorry, go on.
So if you're actually thinking about like using Vulkan in the future, this is a really damn good website. So it actually like tells you through a updated list of devices that actually like go through the survey. It will actually tell you like what certain devices actually have features, what each GPU has. So for example, if you want to type in like the GPU that you have or a GPU that you're curious about having. So for example, if you click on, let's say 5090 or whatever, I don't fucking care.
2070 Super.
So 2070 Super. So you can see like the 2070 Super, and you can see all the different like little things, and see like the vendor. You can see the OS. You can see like the drivers. You can see each instance of somebody with that GPU. So let's click on like the first one, for example.
Sure.
Or just one of them. I don't fucking care. So you can actually see the individual report of each GPU. And unless specified, is that you won't be able to know who's which. So if you can look at the device, you can see like driver version, you can see the instance version that they can actually support, and
you can see who like contributed to the data set. Oh yeah, I see what's going on. So tisk storage input output 16 is false. Tisk motherfucking tisk. That is a very long report, but I can see how it would be useful if you're like concerned about a very
that's
specific
how
feature.
many different things that Vulkan supports and has.
Yeah, that seems about right.
That is the beauty of it.
I mean, at the
you don't have to like turn on all of them too. It's like that's the neat thing about it. It's that fine-tooth control.
Yeah, definitely. Like that's what I was gonna say. Does seem nice. Is it does seem like one of those things where like it does seem granular, more or less, right? Like it's like as like if you were working at a very specific project workload, you're probably going to be specifying like hardware requirements and shit like that, anyways, right? So I can definitely see this as like a benefit. Nothing bold there. Just yep. Let's see. I think we're right here. Let's see. Yeah, right there. Because everything in Vulkan is pre-built by default, this means that most state validation on the GPU will be done when you create an object, and the rendering itself does less work and is faster. Good understanding how the object... Oh, no, we read that one already. Ha ha ha. Let's see. When doing actual GPU commands, all the work on the GPU can be recorded into command... No, we read that one as well. There's no concept of a frame in Vulkan. This means that the way you render is entirely up to you. The only thing that matters to you is you have to display the frame on screen. Which is done through a swap chain. New terminology to me. When there's no fundamental... Oh my god. But there's no fundamental difference between rendering and sending the images over the network, or saving the images into a file, or displaying...
To kind of clarify for you, Volbike, a swap chain is the set of images that is connected directly to the GPU that is used specifically for presenting onto a screen or monitor.
Okay, so... I'm trying to think of like how to like... You know, let's just see if there's an image for it. Swap chain. Whoop, that's the wrong thing. Okay, so is the way that it works is basically you have like an A... Okay, so what this image is telling me is that you effectively have an A-B buffer, and then while A is being displayed, you show B, and then once B is done, and you switch to showing B, and then A gets cleared and redone. Is that basically what it is?
There's pretty much like the whole idea of like double buffering and
Triple buffering,
like even, but... Yeah. In practice, double buffering is kind of like all you need is essentially while an image is being displayed, you draw and render onto the other one, and as soon as that is one, you then you then present that one, and then you again start rendering onto the other image.
I think this kind of shows an okay example of it. For those of you.
And then there's the more fine-tooth concept called frame in flight, which is kind of related to the double buffering, where you kind of like use like two resources, but it's more about getting the GPU, or not the GPU, the CPU to immediately start rendering the next frame immediately after presenting, so that way you don't have to constantly wait for it to be done.
That's fair. You should render dial-up internet style 1 pixel at a time sequentially. I think anybody who would want to play my game would want to fucking die. Guess what? This game's only playable if you fucking open it in Final Cut and set the speed to 100x. No, that's fair. Because like the like thing is that I'll say is like very weird for me right now is, effectively speaking, there's so many things that I can think of that I've seen and like oddities and whatever, right? Which, like, you know, like when you're like playing a game, like an abstract, you're like, oh, that's stupid. And then it's like, even with this just sniffing the fucking farts of what was once there, 5 years later, I'm still like, oh shit, this is giving me like a lot of context for things, right? So, you know, mind is racing with ideas. So that's good or terrible. One or the other. Let's see. Oh yeah, we didn't read the last sentence. So where are we at? But there's no fundamental difference between rendering and sending the images over the network, or saving the images into a file, or displaying it on the screen through the swap chain. This means that it's possible to use Vulkan in an entirely headless mode, where nothing is displayed to the screen. You can render images and then store them into the disk, very useful for testing, or use Vulkan as a way to perform GPU calculations, such as a ray tracer or other compute tasks. Holy shit, sorry, I'm imagining saving like half an hour of like simulated playtesting, like uncompressed to the fucking disk. Oh, that would be painful. Oh, is there any amazing thing? Another reason to use Vulkan is to use features that OpenGL simply doesn't have, such as ray tracing. Hey, both to what specifically, MegaCat? Let's see. Let's see. Okay, none of those seem extra useful, so we will carry on. Okay, Vulkan main objects under use.
Of it's saying like there's no concept of a frame in Vulkan. That's very useful.
Yes, definitely. I'm sure that'll be a lot more useful when I get a little bit more into it. But I mean, like, it does make sense. Like it actually, like, cause I'm thinking of like a bunch of stuff where it's like I'm thinking of like what do you call it, like with like a game as an example, right? Like I'm thinking one thing you can effectively do is in a scene, you know, process all the shaders and stuff for like this is probably like some very old like PS1 level fucking rendering, right? But like what I'm basically imagining is like you know, you basically rendering the screen, and then any physics objects would be passed to the CPU, because, you know, the CPU would crunch those like math calculations a lot faster, as far as I'm aware, right? And then yeah, so like it makes complete sense. So basically, you know, it's kind of like a double async thing, but it ends up working out, and then huzzah! Let's see. Vulkan main objects and their use. VK instance, the Vulkan context used to access drivers. VK physical device, a GPU used to query physical GPU details like features, capabilities, memory size, etc. I imagine that one's used a lot in AAA games. VK device.
I missed it. What was it?
VK physical device, a GPU query. Used to query physical GPU details.
Oh yeah, pretty much it's going through the entire order of like what you would need to set up. So for example, you would need to set the instance to actually start using Vulkan. You're gonna have to grab like the list of GPUs, and you're gonna have to pretty much select the best like physical device to actually create your device out of. And after that, you kind of allocate all your buffers, like for example your vertex and index buffers for your meshes, storage buffers for computing, uniform buffers for say storing transformations and how to like move a object around into space. Then you got your VK image, which is things like for your textures or swap chain images. Pipeline is your pretty much your shaders, pretty much. Yep, rasterization objects, and it pretty much goes to the end.
Yeah. VK render pass holds the information about the images you're running into. All drawing commands have to be done by render pass. Only used in legacy VK guide. Okay, so I guess that's just appreciated. VK frame buffer holds the target images for a render pass used in legacy VK guide. VK command buffer enables GPU commands. All execution that is performed on the GPU itself. Now the driver has to be encoded in a VK command buffer. VK queue execution port for commands. GPUs will have a set of queues with different properties. Some only allow graphics commands, others only allow memory commands, etc. Command buffers are executed by submitting them into a queue, which will copy the rendering commands into the GPU for execution. Okay, that explains that previous thing that we were fucking confused by. And by we, I mean me, because let's be real, you're better at this than me. VK descriptor set holds the binding information that connects the shader inputs such as data as VK buffer resources and VK image textures. Think of it as a set of GPU side pointers that you bind once. Okay. VK swap chain KHR holds the image for the screen and allows you to render things into a visible window. The KHR suffix shows that the command comes from the extension, which in this case is VK underscore KHR underscore swap chain. What does KHR stand for, if you know?
Chronos. That's essentially the vendor where the extension originates from.
Okay, fair enough.
So you will see like NV for NVIDIA, AMD for AMD.
Yeah, that's what to say.
And then EXT for experimental extension that is kind of agnostic, but and then you also see like Google and Huawei and all that.
Yeah, totally. Is CHR kind of generally like the global one, and then you basically have like vendor specific ones if needed, or is it like some other?
Yeah, KHR is the more global one, and those are like the most likely to be, you know, more vigorously supported, and also more likely to be promoted into major versions.
That's fair. Is it at all a thing where, like, you know, like AMD's version, like, is there really like a performance benefit to it, or like not really?
Sometimes.
Sometimes, yeah. the famous programmer response.
It's kind of the unfortunate, because it really fucking depends.
No, that's true. Like would the general like 80% be like generally not?
Generally not.
Yeah, okay. That's what I was thinking.
You will see like some patterns where like it's better on NVIDIA and sometimes it's like better on AMD. And so you have to kind of like pay attention to which vendor it is, so you can turn on like which optimizations or like which way you do it. Yeah,
totally. Because I can totally see, like, immediately I can totally see things where it's like, oh hey, if AMD GPU within this set of generations or whatever, you know, then use this specific swap chain for doing special things, because, you know, NVIDIA paid us money or AMD paid us money, and, you know, they really want to make sure the GPU performs good, right? So that's a very cynical look at it, but I can see things like that, right? Let's see. VK semaphore synchronizes GPU to GPU extension of commands used for synchronizing multiple command buffer submissions one after another. VK fence synchronizes GPU to CPU execution of commands used to know if a command has finished being executed on the GPU. Cool. I feel like I had something to say, but not really. So I guess I'll keep rolling. High-level Vulkan application flow, engine initialization. First, everything is initialized. To initialize Vulkan, you start by creating a VK instance. From the VK instance, you query the list of VK physical device handles available in the machine. For example, yeah, this is basically everything you just said. I'm just gonna keep reading but yep. If the computer had both a dedicated GPU and integrated graphics, there would be a VK physical device for each. After creating the limits and features of the available VK physical device handles, you create a VK device from it. With a VK device, you then get VKQ handles on it or from it, allowing you to execute commands. Then you initialize VK swap chain KHR. Chronos alongside the VKQ handles. You create VK command pool objects that enable you to allocate commands from the buffer, command buffers from them. Huh. So basically, long story short, a slightly more wordy version of basically what do you call it, like networking, but the whole create port, bind to port, listen to port. Yeah. Oh yeah. I now remember what I was going to ask when I was reading that as well. Is so I know NVIDIA has the designated CUDA language and whatever AMD's equivalent is, because let's be real, nobody ever talks about it, right?
ROCm, yeah.
Yeah. So is there a significant difference between those and Vulkan, or not really? Sorry. From a performance app perspective.
Oh, there's absolutely. CUDA and ROCm are kind of both superior to Vulkan's SPURV, especially for computing. Mm-hmm. But all of them still employ the dedicated cores for them. It's just in my opinion, it just feels like the Vulkan CUDA is kind of an afterthought. It will still do the job pretty damn well, but not that you would probably get from CUDA.
Fair enough. So I guess to extend is how much faster let's just say you're only writing a program for NVIDIA, right? Would the CUDA version compared to Vulkan be 2 times, 5 times, 10 times faster? What would be the rough knee jerk that you would expect? Very vague, take with a fucking salt lick.
I've seen anywhere between 1.5 to 150.
Okay, so big range.
Yeah, that's kind of the problem, because that entirely depends on what you're trying to. That's why it's the range is so fucking fast.
No, definitely. I do also imagine part of that is too just the domain of the problem, because I imagine somebody who knows CUDA probably knows CUDA very well, right? As an example,
there's the domain of the problem. There's also the fact that NVCC, which is what you use, can directly talk with the CUDA cores a lot better than SPURV, because it's a mediary language, right? So you have less chances of targeting the hardware better. It's kind of where, even though PlayStation can do Vulkan if it could, you would still choose PSX, which is their graphics API and all that, because it allows you to directly touch the hardware as much as possible. It tells you everything else that is even lower level than what Vulkan can tell you, and you can pretty much really try and get down in there. And it's kind of the main reason that CUDA is superior, and same thing with ROCm and all that. But if you're talking about just getting the job done and doing it well, SPURV can do it.
Yeah.
But if you're trying to make an AI for deep faking for ransom money, you probably want to use CUDA.
I mean, let's also not forget that a fuck ton of AI stuff right now is all Python calls. So, woo.
Oh God, yeah.
Oh yeah, I'm assuming you know the Primogen, so I'm not going to give you an intro on them. TLDR, for anybody who doesn't know, programming YouTuber, right? They apparently were working on like some ML like thing in JavaScript. Like, oh, very very rough.
I can't remember. Wasn't one of those episodes where somebody managed to like find like a security flaw with the AI that he was using and managed to like shut it down? Like, is that the same episode you're talking about?
No. So this was them referring to their college days, right? So this was when they were in like college trying to get like go for their like master's or doctorate or something, right?
Oh yeah.
Yeah. So like what you're referring to, I honestly have no idea, right? I just remember hearing AI and JavaScript. And I'm like, wow, that seems like the polar opposite of what you want, because as far as I'm aware, with AI stuff, you want a lot of cores, right?
Yep.
And man, as mentioned earlier, JavaScript being a very heavily single-threaded language, that sounds very bad. And like, I understand you can technically make it multi-threaded by doing like, you know, like async network requests and stuff. But let's be real, that's not really multi-threading. That's, you know, that's single-threading with a wish. I don't know. Very 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 fun, very silly, very confusing. Let's see. Render loop. Now that everything is ready for rendering, as we did fucking nothing. Feels like there's a bit of a gap here. Like, yeah, you kind of explain the abstract. It's you know, sure. Sorry, this is like a fucking woodworking teacher being like, "Yep, so like here's the project you're gonna do. Have fun, get started." And like every student goes like a different like tool. It's just like, okay.
No fucking. I'm sorry. Somebody fucking send me something. I'm gonna fucking thank you with.
Let's witness this trash real quickly. Oh, okay. What? The creator of C++ is Bjorn Straustrup. I don't know how to say that fucking name because I don't speak that. What the fuck is that image? Is like not them either, isn't it?
It's an AI generated picture of them.
Yeah.
That a news sort, that news site used to like celebrate one of their birthdays, I think. But the AI picked it the fuck up for its overview.
Oh, it's different from mine.
This is the first image that they see.
Oh, that is horrifying. That's like Sean Shup mixed with like fucking like Michael Jackson. Like, I don't know what that image is supposed to be. Like, oh, that's horrifying. Here, you know, let me hide stream.
That's kind of weird because. Hold up. That's kind of weird because your result is different.
Yeah.
Oh my god, it's the same for me.
Really?
I mean, yeah. So that would be.
Maybe it's because we're in like different regions or something. Here, I'm just gonna pull it up.
Yeah, Google does modify the results based off region and what you've searched prior.
Yeah. So okay. So
also, they've been found to intentionally worsen their search results just so you go there more and they can flash your eyes with more advertisements.
Oh yeah.
Going through a lawsuit.
This is the image, and like what's funny, horrifying about it is like, so what was throwing me off so much is that like I see Hitman, and like I know this guy, he has kind of the hardcore side hair going on, right? And like, yeah, here's a better example of it, like this, right? So like when looking at the image, I was like the hair was just close enough to pass, right? So my brain is like flicking a switch back and forth. It was like, it's them, it's not, it's them, it's not, it's them, it's not. It was so bad. Oh, God bless AI. It is exclusively going to make the world a better place, I'm sure of it. I have to like shake that one off. Anyways, I guess slamming forward. Render loop. Now that everything is ready for rendering, you first must ask the VK swap chain Chronos for an image to render. Or sorry, to an image to render to. Then you allocate a VK command buffer from a VK command buffer pool, or reuse an already allocated command buffer that has finished execution, and start the command buffer, which allows you to write commands into it. Next, you begin rendering by starting a VK render pass. This can be done with a normal VK render pass or using dynamic rendering. The render pass specifies that you are rendering to the image requested from the swap chain. Then create a loop where you bind a VK pipeline, bind to some VK descriptor set resource for the shader parameters, bind the vertex buffers, and then execute a draw call. Once you're finished with drawing with the drawing for a pass, you end the VK render pass. If there's nothing more to render, you end the VK command buffer. Finally, you submit the command buffer into the queue for rendering. This will begin execution of the commands in the command buffer on the GPU. If you want to display the result of the rendering, you present the image you have rendered to the screen. Because the execution may not be finished yet, you may want you use a semaphore to make the presentation of the image to the screen to wait until rendering is finished. Pseudocode of a render loop in Vulkan. I was about to say, I hope this is an actual code because this feels like a fucking jump. A swap chain for the index of the swap chain, so we can render it to int image index, all that. So yeah, so this in my brain is when you're setting the frame buffer size, is just literally just changing like the value of that, basically. Like not exactly that, but like, you know, the like buffer that you're working with or whatever. Let's see, create a new command buffer, VK command buffer command equals allocate command buffer, initialize the command buffer, VK begin command buffer command, start new render pass with the image from the swap chain as a target to render to. Each frame buffer refers to an image on the swap chain. VK command begin render pass command. Let's see, rendering all objects for objects in pass objects, bind the shaders to the configuration used to render the object. VK bind command pipeline command object.pipeline, bind the vertex and index buffers to the rendering object. VK bind vertex buffers, command object vertex buffer to VK command bind index buffer, command object and buffer. Bind the descriptor sets for the object shader inputs. VK command bind descriptor sets, command object dot texture descriptor set. VK bind descriptor sets, command object dot parameters descriptor set. Execute drawing. VK command draw CMD. So I know this is pseudocode, so don't hold me too hard to this. But so is VK command begin render pass? Would this effectively just be like what is? This is throwing me off because like the way that I mentally map this is being like, okay, GPU go do things, and then the draw is what's messing with me here.
So how do I explain a render pass? So render pass is pretty much like all of the let's see. Give me a damn minute.
Would it be effectively
it's pretty
like
much
this?
like a collection of attachments, subpasses, the dependencies between them, and pretty much like how the like attachments. So the attachments would pretty much mean like the images, your depth image for like Z testing and all that are pretty much going to be like used all throughout your entire like rendering operations, right? And the render pass kind of goes through the entire like step-by-step guideline of how like the images like should and need to be drawn, right?
Yeah.
So with VK begin render pass, it's saying, okay, you see all these images or these like like pretty much like start with these operations, right? You are allowed to just like draw on them. Essentially, it's like the ready set go with all the rendering commands that you're going to be doing, like binding the pipeline, setting all your buffers, setting all your uniforms on all that, or descriptor sets technically, and then setting up all your draws, right? So the beginning render pass and the end render pass helps kind of like package all of your draw calls to the specific set of images that you want to draw into.
Okay.
And the reason that you want to do begin render pass is because the render pass is related to your frame buffer and your pipeline. The pipeline takes in the render pass, so that way it knows what kind of images it should expect and draw into, right?
Mhm.
And then the frame buffer is the set of images that is compliant with the render pass that is going to be also compatible with the pipeline. Does that make sense?
So the one thing that threw me off there, so I'll just add this, I guess. It's like Blender is where I'm semi-familiar with like the render separations, right? So if we go into here, I think there's a Z index or something, or not, depth, I think is what it might be. I think it's like right here. Nah, it's not really showing it. Anyways, basically, long story short, is there is a way that you can separate pretty much what you're talking about, and I'm almost certain it's more or less what you're talking about is in Blender, right?
Yeah.
I just want to take a quick glance just in case it's in here, because it's literally just a list of like checkboxes you can toggle for like the export, right? I don't see it. Oh, is this it? Yeah, okay, it's like right here, like combined, which would be like all the layers combined, Z, mist, normal, position, vector, and like things like that. I think like this is obviously like a more abstracted version, but this is basically what I'm thinking of, and you can like, you know, you could have like the Z, which is your depth map, right? So
Yep.
So basically, I think this is a much more baby version of what you're referring to, right? The part that was confusing me was the part where you were mentioning the buffer, because it sounds like you were doing the buffer at the same time, like in like, what is it, like parallel but asynchronous, right?
Like the frame of flight, where you present a frame and then you render it at the same time that you right after you, or at the same time that you're presenting. Is that what you're kind of going with, or?
Okay. Let me quickly spam down Krita so I can do a little 2-second scribble, which will probably help a lot.
Yeah.
It's very tiny because I just want to make sure that I have like an understanding of it, right? Because I think I get it, but I'm not certain, and I think it would be better to get clarification than being like, whatever, move on, right? So let's see. Let's very quickly slam into Krita. So what I am kind of sniffing from what you just explained, once this is done, I forgot how long Krita takes to start up. Come on, you can do it. There we are. New image. Sure, that resolution is great. Okay, so oh wait, I should probably rotate this if possible. Can I do a quick rotate? No. Oh wait, I can just do this. Haha, cheat. Anyways, okay. So the way that I'm imagining the frame buffer now, because again I'm hyper newbie on this, so I apologize, right? But so what I'm imagining is, so like let's say we have like 2 frame buffers, right? The way that I'm imagining it is, so basically you like, you know, at time, you know, 0, right? It's like frame 0. Let me do this slightly better. So we'll do like F0, right? Frame 0, we start, and then, you know, you start doing like the various things, right? So like I don't know all the passes, but let's just do something simple like color. So we'll do like color. We'll do like shading, like matteness or whatever, right? Like what do you call it? Like roughness. There we go. That'd be better, right? Like roughness. Let's pretend that's all the steps, and then, you know, we'll have like E, which is like export to the monitor, right? Like go away, right? Yeah. Is it fair to say that, like, let's say right here, frame 1 might start rendering, and then, you know, the similar cycle goes like, you know, S R sorry, that's incorrect. C S R E. And then when this one gets exported, this frame right here can effectively start. Is that kind of what's happening with the frame buffers? Like
so essentially, as soon as you like finish like presenting, so what you're saying is like when the first frame is presenting,
mm-hmm.
you immediately start rendering and doing the operations on the second frame.
Somewhat, yeah. So basically, once all the data for a frame is collected, then basically like all the render passes that start happening, and then basically frame 2 can start processing like at the exact same time, right? Is that kind of what's happening? Like, I know it's kind of.
So as soon as your first frame renders,
mm-hmm.
you would do a present, on the first frame, like show it to the monitor,
Yeah.
and then you would immediately start doing it. But that does not mean you have to wait for the presentation to actually finish. You can immediately start going.
Yes. So I think that's kind of what I'm showing here. So like instead of like being like frame 1 export, frame 2 export, you see more of like an overlap, kind of like I'm showing here, just poorly done. Is that somewhat accurate? Like, not obviously, but like, does it kind of make sense?
With the Firefly model, yeah.
Cool. Yeah, because it's very vague, but yeah. So like, I guess I'll leave this open because
The problem is like you can either like stack it like that, or you could literally just do it render pause, pause render.
Mm-hmm.
You could do like that stack, or you could do the frame with like where you immediately start going at the next frame.
Okay, yeah. So one more question, just because like now my mind's thinking is like if you have more of an asynchronous frame approach, is there like instances? I imagine this is highly inefficient, but like is there really instances where like you have to worry about like frame validation, where like if let's say you're doing like an A-B thing and you're expecting B but A finishes first, do you just like ignore B and like there's a bunch of frame validation stuff that goes on? Or is that just some made-up BS that I'm imagining in my head?
For this situation, it's not really something that you have to worry about too much.
Yeah, because I would expect
because-
each frame to be somewhat consistent to render, right? So like the chance that one is suddenly faster does seem odd.
Yeah, you pretty much like do your first frame,
Mm-hmm.
you present, and then as soon as you present, you immediately start the second frame, and then when you kind of present onto the second frame,
Mm-hmm.
that's when you would wait for like the first frame to actually like present and be available,
Mm-hmm.
and then you can like grab frame 1 again. You would then wait for frame 2 stuff to finish after presenting, so then you can work on frame 2 and all that.
Okay. Yeah, sorry. So I think there was a slight. So I think I was half right. What I'm basically hearing is so if you have like whoops, I think I'm on erase mode. Yep. So like let's say I have like I'm gonna make this a little bit smaller. So like let's say you have like frame A and then frame B. Like this is the AB of the images, right? I don't know why I did A twice there. Very very smart. Basically with the whole color, roughness, and then like export, because the monitor and all that stuff is going to be so long to a machine. Basically when the export happens, let's say the export takes this duration, this frame still needs to be saved, but then frame B is basically right here, doing the create, roughness, shade, and then hopefully by the time the export is finished here, then there's a new like export here ready. Is that more accurate? Very loose, drawn.
Pretty much.
Cool.
So, yeah, pretty much what you do is you kind of, if you have an if there's a need to wait, you do a little wait, so that way the frame that you're trying to like present like to basically go gets finished. Because that way when you actually try to acquire an image, it's most likely going to be free at that time. So then you can grab the image, and then you can do all the stuff that you want. Cool.
Yeah, I think
yeah, it's pretty much going to behave somewhat like that. Yes.
Cool. Okay. Yeah. Like obviously this is a fuck ton of asterisks. Fucking.
Yeah.
fucking not at all like hyper applicable, but it's I'm a little baby. I'm trying to understand. Yeah, I think that makes sense. I think that makes sense because like, I'll add this like from like a Blender perspective. I have a good concept of like that's probably a bad example, but like I have a concept of stuff like this, right? I'm just baby child.
Like the physically based rendering where you have like your albedo, you have like again your roughest, specular, ambient. All your other geometric data stored as images. So yeah, all of that would be like part of the frame buffer that's like attached to the render pass. That the pipeline that's also compatible with that render pass will draw directly into.
No, that's fair. That's fair. So would this right here be like a more accurate example of like a render pass, and basically all the images are stitched together?
The render pass is kind of like the set of images that you're going to be drawing onto,
Yeah.
and then the set of what we call subpasses, which are the actual like different stages of drawing
Okay.
and transitioning, and what we mean by transitioning is like changing the layout of the image pretty much, from like shadery to color outputs, or actually the converse, because that's fucking stupid, but and that actually helps with or like categorizing like all the draws that you're going to do and all the permissions, even that what each like pipeline of random pass is going to do.
Yeah, I think this will be something where like I think this right here probably aligns best with what you're saying, and then long story short is like to get it further, I'll probably just need to play with it and kind of get more of that like intrinsic understanding, you know,
Yeah.
or instinctual understanding. But I think I grasp it. Yeah, so it was a hot minute for that. That's the exact same comment. Yep. Let's see. Project layout and libraries. For the Vulkan engine, we use a specific folder layout. /assets will contain textures and 3D models that we use over the guide. /bin is where the executable will get built. We don't use the normal CMake build folders to simplify the path for the build assets. To simplify the path to assets and shaders. /shaders will contain all of our shaders. Their compiled layout. Dash chapter dash n folder contains the code for each of the chapters of the guide. /third party contains all the libraries we use vendor in, so all of our source code is readily available. Let's see, libraries. On the engine, we use a set of libraries most stored in /third party. The only library that isn't vendored is SDL. I forget what SDL is. Simple direct media layer. Oh yeah, this thing. Hardware extraction layer. Yeah. Okay. Yeah. I should actually look more into that as well. Let's see. The main libraries we're using. GLM, OpenGL Mathematics library, header only. We use this for the matrix and vector math functionality. It is a library that contains types that are directly compatible with GLSL types in most cases. For example, a GLM that references mat4 has a similar operation, is directly compatible with a mat4 in a shader. While it says OpenGL in the name, it works great with Vulkan. Actually, here's a side question, because this just had me fucking... This is something I was thinking of the other day. So, as I'm sure you're aware, stuff like C++, like the integer size is non-standard, right?
Yeah.
How common is it for people to use a library or something to like redefine types, like a forced integer size? Like, is that a very common thing, or is that more rare?
It's extremely common, especially
Okay.
with stuff where you need to have like an exact size. There's already std and .h.
std and .h library. I will pin this.
stdint.h.
Oops. Well, good thing it came up
So
anyways.
standard integer.
Yeah.
So it'll actually give you a bunch of types where you'll get like 8-inch signed, 8-inch or 8-bit unsigned,
Yeah.
32-bit, 64-bit, and then the float double is pretty much going to be 3264. So you're not going to have to worry about damn shit. The only one that's kind of like ill-defined is like long double, because that could be just 10 bytes or 16. But
No, that's fair. Cause like most of my stuff that I've played with, like I haven't worked on a serious project yet, right? So I've heard issues related to this, right? But like I have no idea how actually common it is, cause like I can see some things that just doesn't matter, and I can see other instances where it's like hypercritical. So yeah, it's a whole fucking mess I can see.
yeah, it's a yes and no thing. So like a lot of the code, like you can probably just get away with like using the ambiguous like data types, and a lot of it is kind of standardized to where like int is like 4, long is 8, and all of that bullshit.
Yeah.
Short is 2 and char is 1, but technically like a char isn't even guaranteed to be like 8 bits. It's like the minimum guarantee, so it can be like technically 7, 9, or 11 if we're talking about like the PDP computers back when fucking grandpa was slaving away in the mines, but who the fuck cares about that shit? So there's enough like ubiquitousness to where you don't have to like worry about any of that. But when you need like stuff to have like a proper padding, proper size, proper like indentation, all of that, you want that certainty.
Definitely. Definitely. And I also imagine just having forced data sizes just massively reduces the headache of like bugs, right? Like, oh, it doesn't work on my system, and then you fucking spend hours like bug testing. You're like, oh, it's because it suddenly got compressed or expanded. Yeah, that makes a lot of sense. Yeah, I just again like I've only ever used it in like pet projects, right? I imagine the biggest place it would actually be an issue would probably be mobile if I had to sniff test, right? Because my inclination is that most desktops have all been standardized pretty much the same, right? But it's like mobile where like every competitor is effectively fighting to be like as efficient as possible is where it becomes like a pain, right? Specifically on like budget phones, I would imagine, but that's just an assumption.
Yeah, the desktop kind of stuff kind of has like a similar enough architecture. But there's also just like physical limitations with the mobile stuff that kind of like makes it a little bit more difficult.
Yeah.
So, because of the low power draw that needs to do is like mobile phones need to use like a tile-based GPU, which is instead of like doing like little 2x2 subgroup chunks that you might be familiar with on like a desktop GPU, you would need to do everything in like little 16x16 or 32x32 bits because that's like cheaper for it to do, right? So
yeah, actually I think something very similar to what this is something I had to struggle with in Blender. I don't think Blender takes long to launch. Nope. There's actually this fun little thing where I forget what the setting is, but there was a setting in here which was not samples, but it was something silly. Oh, it's tile size. That's what I'm looking for. Tile, where one of the Blender tricks that you learn is if you're in cycles, you actually have to mess with your tile size, which is like, the XY of the tile, right? And I remember there being like significant differences with this where like you could unironically like half or double your performance by like either having or doubling the number. So yeah, Blender trick. So my effective understanding is that Blender kind of forces it where the tile-based GPUs that you're mentioning for like mobile would be more like implicit, where it's like it'll render chunks instead of like like a tile. So it's supposed to be stuff. I don't know. I'm abstracting it in a way that makes sense to me. God damn it. Because I've honestly never heard of a tile render GPU before. Because again, very 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 bitch boy stance. I've kind of okay. Sorry, I just glanced at OBS for 2 seconds and my CPU usage went like 9.3 and then like 2.93 e to the power of 6. And then back to 9.3. I'm like, whoa.
What the fuck?
I don't know what it was. I was so confused.
Huh?
Yeah. It was in. I'll send it to you for anybody who doesn't know. Look up like the OBS like status window, but it's fucking this. So the number in the upper left there, it just jumped from 9.3 to fucking again 2.83 to the power of whatever the fuck. And I'm like, what? It was literally for like fucking like a tenth of a second. It was just like, okay, sure, I guess. Well, if the stream crashes, OBS is shitting the bed. Anyways. Yeah, I guess rolling on with the fucking library. Let's see. SDL windowing input library. Simply built. SDL is one of the most used libraries to create a window and access input devices with a cross-platform way. SDL works on almost every platform and is very well supported. Used on Unreal Engine, Unity, Source, and others. What Source? No. We use it in the project to have an easy and fast way to open a window and have a dedicated keyboard input. That makes me feel a lot better about about using things like SDL. Ha ha ha. You know, I might as well just open all of these, because why not? Because I imagine I'm going to have to play with these at some point, so... Ha 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 ha. Cool. Let's see. Dear IMGUI, yeah. Easy to use intermediate graphic user interface, GUI library, graphical user interface. I don't know why I fucked that up. This allows us to create editable widgets such as sliders and windows for the user interface. It is widely used in the game industry for debugging tools. In the project, we use it to create interactive options for rendering, STB image, image loading library, header only, small and easy to use library to load image files. It can load common image types such as bump, ping, and JPEG. And others. It is part of a set and other similar single file libraries. Tiny object loader, .obj model loader library, header only, fast and small library to load the .obj 3D model format that we use when loading 3D models. VK Bootstrap extracts a big amount of boilerplate that Vulkan has when setting up. Most of the code is written once and never touched again, so we will...
Vulkan Stairwalker? Yeah, pretty much. This type of shit was... the stare of, like, fear, freezing, and regret just diving into this shit.
No, I mean, I honestly, personally, at least, don't regret this at all, because... I enjoy challenges because I'm a dirty masochistic slut. But no, like I enjoy challenges.
What do you mean by that?
It means I want to get fucked up.
Damn, boy.
Nah, I mean,
Say no more.
It brings all those Daddy Ari comics into a whole new context.
Oh hell no! Hell no! Yeah, I already got people like trying to fucking threaten me with like drawing porn to me. It's like, no.
I've actually said on stream like half as a joke, like fucking if I get fucking like pregnant porn, I'll frame it and like hang it in my bathroom.
Why in your bathroom?
Because I think it'd be fucking funny, like eye level with the shitter. So you're just sitting there, you have to just stare at it. Chill out, Foxboy. Never. I love the chaotic energy. But yeah, no. Anyways, I guess with what I was trying to say was nah. So like it's one of those things for like me personally, where like I enjoy learning and understanding. Right. Get coding. I'm working on it. But yeah, like I enjoy learning and understanding, right? And like it's one of those things where when I struggle with something, I don't get I only get upset if I don't see a practical use for it, right?
Yeah.
Like as an example is so the classes, like for context, in a high school I miss like all of my pre-calc classes, so like I'm like slamming through those right now, right? That's why I needed the quadratic thing, right? And like when it comes to like trig, I fucking slam trig like dead easy, right? Like there's like one formula that like I kind of like struggled with, that's just because it's kind of like a long semi-obtuse one, right? But like it worked. And I was super cool with trig because it's like, yeah, I see a practical use for this, I understand it, like I'm engaged, right? And then with the aforementioned quadratics, I'm fucking staring at that shit. I'm like, when is this going to be practical? Like, the examples that you're giving me don't even seem like they fucking have any practical use, you know? So that's fun. Smart byte lore, I mean, I suppose. I like how...
The quadratics, like, it's only going to be in, like, computer graphics, like, if you're coding up the engine. Because
yeah,
when you do, like, ray intersects with like spheres, it's pretty much equivalent to solving quadratics.
Okay, well, it's nice to know that there's one very niche use case for it that I'll probably Google it for and then completely forget about it past that. Yeah, because I don't know, because like with my abstraction, right? It's like, man, like trig is going to be used fucking everywhere, right? It's used in like the UI, it's used in fucking like the rendering, it's used with like meshes, it's used everywhere, right? And then it's like the quadratics thing. You have given me the first computer-related thing that I can think of that I'm aware of quadratics being useful, right? Because like on like a fucking test, it's like Janice has 20 nickel, or sorry, like 20. No, what is it? They have 20
apples.
Yeah, but no, like one of the actual test questions is like these numbers are bullshitted because like I don't remember right, but it's like, you know, like Janet has like 23 coins, it totals up to 490. You know how, you know, the coins are only made up of quarters and dimes. How many of each coin do they have? And it's like, fucking what? If I was a real person, I would just look at the hand and just like separate them very quickly and then like bam, right? Like, I'm not fucking using a a fucking polynomial to fucking solve a fucking coin problem, you know? Fucking goddamn, bring a fucking shotgun to a fucking nursery. Like, oh, damn. So you're not a real person, I knew it. Is that Windows 11 you're looking at? No, it's not. It's Linux. It's Linux. Can I do NeoFetch? Do I have NeoFetch installed? Neo.
What distro you running, bitch boy?
Mangaro.
Yeah. Good choice.
Yeah, I mean, like, here's the thing, right? I understand all the complaints people have about Manjaro. Somehow, it has been the most stable distro for me.
If that's what Modern Linux does, it's like it actually looks pretty damn good.
Modern Linux is honestly really solid. I am kind of sitting on the footage for a Linux tutorial right now. I actually do intend to make a video about migrating to Linux at some point, Waka. I'm hoping to have it released within like a month. That is my goal. No commitment to it, but that's my goal. And yeah, Linux is cool. And there's also many other looks of Linux. Anyways, let's not turn this into a live stream. Let's see. VK boot. Oh yeah, sorry, we got that. Let's see. This library simplifies instance creation, swap chain creation, and extension loading. It'll be removed from the project eventually in an optional chapter that explains how to initialize Vulkan boilerplate the manual way. Do you find that the manual initialization is really worth it, or do you think it's like kind of just a whatever thing?
If you kind of like require like all your extensions to like be there, you can absolutely just use the Vulkan bootstrap.
Cool.
But if you want to have your system where it has like a list of extensions that you need to have, and then a list of extensions that you would like to have. If it's there, enable it. If not, cool, we'll find a way. Then it's probably better to just kind of try to run it. But then again, VK Bootstrap, I think you can kind of do that anyways. You just have to do the must shit stuff like beforehand.
Totally fair. You find it worth it? I have no idea what we're talking about. I mean, hey, gotta love noise in the signal, Waka. And then let's see. Last but not least, VMA Vulkan Memory Allocator implements memory allocators for Vulkan header only. In Vulkan, the user has to deal with the memory allocation of buffers, images, and other resources in their own. This can be very difficult to get right in the performance safe way. Vulkan Memory Allocator does it for us and allows us to simplify the creation of images and other resources. Widely used in personal Vulkan engines or smaller scale projects like emulators. Very high-end projects like Unreal Engine or AAA engines write their own memory allocators. That kind of makes sense. So one more thing too, actually, is the memory arenas that I was talking about earlier. Do you see those very often, or are they more of a rarity?
Which ones? The Vulkan memory allocators?
No, actually, sorry. So what I mean is like C/C++ style like allocators, like memory arenas. Are those very common, or are they kind of rare?
So like, are the like custom allocators like rare to see, for example?
Yeah. Okay. So
you might have to ask your whole question because I think I missed some details.
No, it's all good. So as an example, there's frick, I forgot his name. What's Epic's debugger called again? Rad debugger. Rad debugger. Yeah. So I was watching one of the major contributors here, Ryan Fleury. There we go. This guy, I was watching one of his videos, right, and he was talking about how ari-atori basically introduced him to the concept of memory arenas, and I started looking into them, which is effectively you just reserve a block of memory as an array. You basically make like a mini stack, right? And then use that mini stack as basically like a predefined chunk of memory, that you like read and write to.
Oh yeah.
Do you see those very, very often, or are those kind of rare?
So as in like allocate like a huge chunk of memory that you can have like other parts of your program just kind of like pick and choose, like that's actually extremely common.
Okay.
And it's kind of like what you should be doing. When you kind of like allocate an entire heap, and then you can kind of break it up into buffers, and then you might see like some sources from vendors like NVIDIA saying that you want to do the same thing with like an individual buffer, but personally I don't really see too much of a problem with that unless you have like an amorphic buffer where you really want to like touch shit up. But if you have like buffers that are like of a constant size, it can make sense to allocate a singular heap of do size, and then chop up into buffers of like constant size.
Yeah, the reason why I ask is because, so like, again, very, very junior, so most of what I know is from basically listening to, seniors talk, right? And so one thing that I remember hearing, and this is, I believe, from one of Ryan's I think this was like one of Ryan. No, this was, I think, Ryan's video. I'm pretty sure it was basically they just said like, yeah, like a lot of people worship Rust because it solves like memory issues, right? And then you basically discover what an arena is, and then you don't really care about Rust anymore. Not always, obviously, but like that, and like that's obviously like a hyper fucking paraphrasing. So like, don't actually take that as like what they said, but like that's like what I took away from it, right? And the way that it was presented made it sound like these like memory arenas were like very rare. So like, I don't know. There we go.
Oh yeah.
So just curious.
The act of like allocating like a huge like heap and then just kind of like subdividing, kind of like which it's actually a common practice.
Okay, cool, yeah, because I had no idea. Let's see, cmake-list.txt. Okay, so I don't have any of these libraries installed currently, I don't think.
Well, time to do so.
Yeah, exactly. So let's see. Let's go, I guess, through the state. So GLM, because I'm gonna need this one. So let's see.
Well, so that's Arch, right? So I can't remember if you use Yum, Pacman, or DNF.
Pacman.
For your package manager. Pacman. So I believe it is Pacman / capital S for install, and then it should be libglm-dev.
Let's just go there. Okay, so we're doing sudo pacman-sy, and then it was glb-dev. You're saying
libglm-dev. This thing.
glm-dev.
Oh, it's libglm is actually one word.
Oh, okay. I know some of it's like space and stuff. Target not found. Is it maybe an underscore? Nope. Okay, well, hello. Let's see. Pacman, glm, lib, glm-dev, because that should probably come up with something.
That's a crazy one.
What's up?
Oh, he's like, I'm surprised that libglm-dev didn't work.
Yeah, a little crazy, right? I mean, maybe there's something here that I'm missing, but I could have sworn it's like, yeah, cd into there, cmake. I don't want to use cmake. I just want to use the fucking... Is it just glm, maybe? Is it just glm? GLM? It's glm. Unless I just download something random. GLM?
Just look at the user include folder and see if it has glm.
I honestly forget what that is.
Root folder or root directory.
Yep.
and then USR,
User
and then include.
Oh, just in there. Yeah.
And then GLM.
We'll just use new of them for this because I can navigate cleanly in here. GL, iMath, GS2, Foundation, Flak, Dolphin.
That looks like it's
GLM.
caps of gold.
Got it.
Oh, hey, there it is.
And this is why I want to use new of them because I'm so much faster with searching. Anyways, yeah, that looks about right. So, okay, cool. Goodbye. Okay, so there's GLM done. Bam. I should not do that actually. I should pin it for later reading because.
Oh yeah.
Not a bad idea.
I mean, as much as you're like illiterate as like about graphics, you're already kind of doing better than. You know who Thread Interactive is?
One more time, sorry. Who?
You know who Thread Interactive is?
No.
One of the people who kind of like kickstarted the whole like why a game does killing your game kind of thing. You're kind of doing better than him. He pretty much gave up at the OpenGL because he couldn't handle the linear algebra.
Thread Interactive, YouTube, I think.
Thread Interactive.
Oh, Thread.
So
I heard Thread.
my bad.
No, it's probably me being stupid. Let's be real. I just never heard of the channel, so maybe I know them. I'm trying to recognize their face. They look vaguely familiar. I think I've watched like 2 of their videos or something, or like one of them even. I'm getting a like a whiff of familiarity, but not like, you know, like, oh yeah. I think I watched this video actually. I think this is the one video I've watched of theirs because that looks familiar.
Yep.
Yeah, I mean, considering that's one of their pop-off videos, that's probably the one that I contributed to. But yeah, no, that's totally fair. Like, I'm not. How do I put this? So in regards to my mentality and doing okay is so for me, you are here, so you're a massive like space filler, right? If they were doing it solo, I could definitely see it being more of a pain. The second thing is that it could also just be a different approach of mentality. Like, for instance, I'm approaching this with the mentality of like, I'm stupid but capable, right?
He actually had help. He was actually in the graphics programming server before I initially joined. I can't recall exactly why, other than the fact that he's a dick, but he did get banned in the end.
Well then.
And he in, you know, the whole like learnopengl.com kind of thing, that website.
Yeah, I'm
arguably probably the like easiest like website for like entry like graphics programming. He gave up on that one, so you're doing miles better.
Yeah, I mean, it might just be mentality. Like
I was hoping you'd do them, so it would have been like a much better impact. But
no, like I'm almost certain I did watch this video, right? Like I'm aware about how they talk about like sub-rendering like triangles can be more complicated, right? So if you have like, you know, like let's say like a 4x4 tile, like as an example, right? You know, like if a triangle only takes up like one of those 4 like, you know, subpixels, right, then like that's a very taxing frame. But like if the triangle covers the whole like pixel or tile, then it's much less taxing, right? I remember that from this video, right? At least I think it's that video. It's like one of these, right? But I don't know, man. I don't know. I don't know. I'm gonna not be an asshole on this, and I'm just gonna say it's probably some mentality difference, right? Like, I will say that Discord servers can be absolutely dog shit for help, right? So like, I don't know, maybe
the graphics programming members can be a little bit of a dick sometimes. So like at the same time they kind of get it, but at the same time there was a reason that he was banned. Oh yeah, no, so it's like
I'm not going to ignore that and make excuses, right? I'm more just saying like yeah, I don't know, like it's basically like, you know, It's like the in crowd versus the out crowd, right? Like they might have gone like a small argument. Fucking in crowd said something, he said something on the same level, but because he's the out crowd, whatever, right? I don't know. I'm trying to be charitable. Anyways, yeah, let's skedaddle forward, shall we? Okay, so I just did the SDL, awesome. But yeah, I don't know. I enjoy being a nerd because for me as well, it's like I enjoy the understanding. Is this the same? This is the same fucking GUI that fucking Godot uses. Goddamn. Okay. Let's see. Did I actually close Yakane? Yakuing? Yakukaki? Okay, let's see. I'm GUI. Oh, also, that was a mistyping.
I'm gonna read a news to you that someone in my server just sent me.
Sure.
250 million bees are now loose. A tractor trailer carrying 70,000 pounds of pollinator hives rolled over on a country road in Washington state on Friday, releasing an eye-popping number of honeybees, the authorities said, according to the New York Times.
Fucking hell yeah.
Fucking amazing.
Oh, God bless. And where was that again? Like what state?
Washington state.
Washington state? That's close. I can start a bee farm right now.
Nice.
Do I have enough gas to get this?
Some of the bees. Come in with nets like SpongeBob.
Leave looking like a fucking raspberry. Like, the fun. Okay. Anyway, so where are we going with this? So I'm GUI didn't have a thing. It bothers me how this is just fucking Godot's GUI. I don't know why it bothers me. It just does. Let's see. Pac-Man. I am GUI. It looks like it's just I'm GUI. I don't have much familiarity with the AUR, so I don't want to use it. I'm more just looking for the Pac-Man.
You could also
just download it.
Yeah, just clone the GitHub repository.
Sure.
Because that actually holds like the backend code and source files separately for you to actually, because it's not necessarily like a shared object library. It's just a collection of like source files and all that.
Totally. Oh, also a major thing that bothers me so much is, like people are like, oh, GitHub should have a download button, right? It's like, my brother in Christ, you click the one colored button on the entire page and then there's download zip. Like, holy shit. Sorry, that's just such a big gripe to me. It just, Okay, this one's apparently STB, so let's see if we have STB. STB. Sure, that looks about the right size. Cool. What's STB again? Yeah, it's the image one, isn't it? Oh, no, this is the... No? Image manipulation. Yeah. Oh, sorry, image manipulation. Whatever. Anyways, carrying on. Oh, wait, shoot. I forgot I was supposed to pin the last one. Oopsies! We got a pin. Okay, here we are. We just did the STB, so we will pin that one to get it out of the way. Why am I suddenly forgetting where pin is? There it is. Let's see. Tiny OBJ loader. Yay! I'm guessing this one is probably not going to have an equivalent, so I'll just download this one, because this one's probably not going to have an equivalent if I had to sniff test it. vkbootstrap.cpp. Yeah, okay. This is a very long file, but I'm guessing they linked me just this one file, so I should just download this one file. Boink. I should skim through that later, so we'll pin it. Let's see, VK memory allocator. Example of how to build. Yeah, I understand that. Okay. Let's see. One more Google time. Huzzah. I will say me having some Linux experience definitely has made this process a lot easier, because I imagine anybody else would be fucking suffering with this. Let's see. Okay, well, I'll try the fucking thing. Vulkan dash memory dash allocator. Did I spell it wrong? Memory, vulkan, allocator. Nope. Okay. I don't know why I'm doing that. I can just do Control U. Huzzah! Okay, let's see.
Sometimes you couldn't you just do like a search with Pac-Man?
I honestly have never tried to search for Pac-Man. Let's see. How to search with Pac-Man. Honestly, most of the time it's like I'm pretty damn close to the command anyways. That it's like, oh, did you mean this thing instead? And it's like, yeah. Let's see. So we'll just do that. Whoops, one more time. Did I go way past it? What? Okay, I guess I didn't save that search for some reason. Vulkan dash memory dash allocator. Excuse me? Is it dash SS that it wants? SS? Am I fucking tripping balls? Search turn this command. Maybe there's no results. Okay. Vulkan memory allocator. Huh? No. Okay. What if we try to go QS again? QS. I'm gonna guess there's nothing. What? Okay. Here. You know what? If just as a sandy check. Let's do Fox. Okay. So it did actually return a result. Okay. So I was doing the command. There was actually no results. Okay. Learn new Pac-Man command today. That's cool. So we'll download the zip bomb. Pin it. Let's see. What is this one again? This one is oh, that was my NeoVim configuration. So I think I got all that done now. Yeah. Okay. Index. Wow, short chapter. Let's see. This is the feedback channel for that. This comments will be removed upon full release was done. Okay. Do you have an idea how I can set up this product for Sea Lion? Very cute. The hyperlink initialized welcome on chapter 0 code walkthrough release the old version. I don't know if I did something wrong. Okay, that's just an error. Gonna ignore. Okay, there's a lot of people complaining. Oh, that's a lot of complaining. Oh, that's a lot of complaining. Okay, I see that comment section is dead. Oh, building the project. Start by saying the git project at that. Okay, say no more. Let's just copy the URL, please and thank you. Doink. Okay, let's see. So go into here. Whoops, I closed Yaku in again because I'm stupid. So we need to go instead to the CD. So let's just figure out where the hell we are. I'm not here. No, Control R. CD, and then it's, what is it again? It's like Control R. Oh no, I think I'm going too back. All right, whatever. No, I'm not tripping, am I? I guess I never went to the test folder. Okay, that's weird. I thought I did. Boink. CD. I think it's literally just home directory dot test. Whoa, that was supposed to be test. Yep. Okay. And then it's git clone, and then whatever the fucking URL is. The hotkey has me so messed up. Come on. I believe in you. There we go. Okay. Bam. Okay. So, am I the most annoying person you've ever seen on Terminal? Terminal?
Strangely, no.
Strangely, no. What do I have right and what do I have wrong so far?
Ooh.
Judge me.
I gotta think about it, but running the same wrong command multiple times you have not done yet.
Fair enough. Let me guess, you've encountered quite a few people who are like, but it's right, think, and just like completely missed it.
Or they would like hit the up key to like grab the previous command, and they would keep using like the wrong syntax command.
Oh yeah, that's painful. Yeah, no, you see, because I tend to work faster than like my body can generally process. So anytime something's wrong, it's like, okay, what did I do wrong? You know, it's very rare. It's like, oh yeah, it's something else's fault. Okay, so we clone the thing. All chapters in the branch contain the example code for this project, and the starting point branch contains the initial empty project setup. I recommend you sync both branches to different folders, and if at one point you get stuck, check out the code in all chapters code. Sorry, check how the code works in the old chapters code. If you want to direct download the code without using Git, just download from these direct links. I'm going to do that anyways because, honestly, I don't have experience cloning from a branch, so that's probably a bad thing. But, hey, who's judging? Oh, no, you can see all of the anime girls I have downloaded. How fucking cringe of me. Let's see, we're going to go home.
Man.
Come on. You can do it. All right, you know what? We're going to do this instead. We're going to go X, home. Where's my test folder? There it is. Bam. And then boink. There we are. Huzzah. Extract. Boink. I should have, I'm just going to do this real quick because I don't want to waste the time. Bam. Open with arc. Extract. Go. I don't care. Did that open into a new thing? Oh, what? I only did one? Whatever. Okay, whatever. Starting point, extract. Just send it? Why can't I send it? I don't really want this that much. All chapters. No, that's the starting point. Extract. Okay, start. I guess I'll just name it as start. Bam. Okay, I don't know why I had to name that one. That's the first time I've ever had to deal with that. Okay, I have no fucking idea why I had to name something start, and I don't see start, but sure. We'll ignore these, because these are just a test to make sure that I had, GPP installed, so, or G++. Yeah, we should probably open that one too, I guess. Extract, okay, what was it? Vulkan memory allocator, VMA. Test that VMA could not be found. Yeah, I'm trying to just extract you, my dude. Just that. There, cool. I don't know why I had to do that. Okay. Anyways, okay, let's see. So we got that. You'll need Visual Studio Code to build the project. The code in the project should work cross-platform, but the guide is Windows-centric. Go fuck yourself. Also, I just realized I'm going to need to very quickly go to here, and I'm going to need CMake, because I have not installed that yet. Did I enter my password wrong? Oh, no, I'm trying to search for it. I'm stupid. Ha ha ha. Look at that. Ari, I crossed the boundary. Aren't you proud of me?
Not bad.
Let's see. Bam. Yeah. Alright. I'm gonna let that run in the background. Okay. Let's see. First install the Vulkan SDK. Sure. We are on the Penguin. Actually, there's probably a Vulkan SDK, isn't there? So I could probably just do something like, what was it? It was like query search.
You can go through the tarballs, so yeah, you can just...
Vulkan. I just want to see if SDK has anything. Vulkan. Ooh, things came up. Ooh, what did that? NVIDIA drivers. That's kind of scary to see. Intel driver.
No, they're usually just drivers.
Yeah, I was about to say it all seems like drivers. So, where's that beautiful tarball?
It should be on the right hand side. They're only going to be doing SDK tarballs from then on. They've stopped doing Ubuntu packages.
Oh, have they? That is probably a good thing, honestly. Isn't Ubuntu kind of like dying? Like I know, like on the corporate side, it's pretty strong because I think Windows only lets people run run Ubuntu, but isn't like Ubuntu as like the Linux distro basically kind of dead? Like, hasn't it fallen off pretty hard?
Not that I'm aware of. It just has the disadvantage that it's not going to be up to date as much. But although there have been influences like PewDiePie who have like probably boosted Arch Linux, for example.
Yeah,
and that might be something, but I haven't really considered that, nor have I ever like heard that Ubuntu is like dead.
Mm-hmm. No, definitely not dead. It's so from from what I have heard, Ubuntu has kind of fallen off because a lot of more like community powered distros are just better at like providing features that people want. Crazy that, right? So like Ubuntu isn't bad. It's just that it's like, unless you're looking for like the most bog standard like Linux distro, then it's like like Ubuntu base basically just does nothing very specifically good except for being like the default, right?
Yeah.
From what I've heard, like obviously I have my own things. I remember trying Ubuntu, fucking hating GNOME, and then moving on. Oh, I'm sorry, I think it's supposed to be GNOME.
Yeah.
I thought I could have sworn. Oh, there it is. Sorry. The having no dash between the SDK and Vulkan just very threw me off there.
Oh dear.
But yeah. Oh yeah. Fun fact is, although this is on a Linux system, if it accidentally crashes, then guess who doesn't have to worry? Vulkan SDK. I am worried, but also not. Vulkan SDK 2. Let's see. Oh wait, no, I don't want to. Oh, that seems like it's doing a lot of things. So this is already done, I guess? Huh? Okay, so if I want to go to test Vulkan SDK, there it is. And let's freaking let's just grab a console real quickly. Bam. My guess is bam, bam, bam. Oh, probably gotta bash it or whatever. Let's see. Isn't it bash that I have to type? Bash. Huh? Well, apparently ran successfully. I don't know what I ran, but sure. Let's see.
Well, that's reassuring.
Oh yeah. Cat. Sources file to, yeah. Okay, yeah. That's all that is. Okay, so let's see. I'm just trying to remember what I want to do here. So I want to do like nvim // oh my gosh, cancel that please. I did that so badly. Oh my god. vim, oh my gosh. Do I have a .zsh installed already? I do. ZSHRC, cool. Don't care, go away. We're gonna like this. We're gonna go tab new. We're gonna go into here. We're gonna very quickly go into test. We're gonna grab the it was in just the Vulkan installation setup.sh. Freaking just bop. Whoop, that hotkey didn't work. And then I can't yank it to my global, so let's do that. New tab. Boink. Okay, bam. X, and then we just want to do source // .zshrc. Boink. Parse error near that. Oh, that's wonderful. Parse error near \n. Oh, because a character accidentally got deleted somehow. Hello, fee. Okay, that should be good now. Let's try the source one more time. Ha! Look at that. Let's see. Vulkan SDK. I should probably just look at these very quickly in in the folder before I go too far. Let's see. So we're just gonna go into here. We're gonna go to the test folder. I need to just do that. CD. Oh no, I need to go into. I guess that should work. Nvim // go away. And then so now I'm just gonna look at Vulkan SDK. Did I go in the wrong folder? No. Vulkan SDK.
Do you need the site to actually get started with the Vulkan SDK?
You know what? I have been completely stupid. I have just not read the README. I don't know why I was ignoring the README there. I'm like, damn, they're just throwing me into the files.
Okay, let me just DM you the link. There you go.
Sure. Let's see. Let's hide the stream for 20 seconds so I can get witnessing. I just don't want to accidentally leak DMs by it. I don't want to accidentally leak DMs because I'm not an asshole. Alright, let's see. Alright, getting started. Cool, thank you. Let's close the thing and then reopen here. There we are. I'm the one hoarding all the hot single furries in your area. Anyways, Let's see. Getting started with the latest version. This guy describes the content. Yeah. I'm not gonna read this because this isn't meant to be this. So I'm just gonna kind of skim it for anybody watching. System requirements. Chronos Vulkan headers. Upgrade. Do they have a Arch version? Oh, they do. Look at that. Ran that earlier. Needs to decompress the SDK. I already decompressed it. Oh, that's a lot of things. Okay. Well, time to run the random command that I found on the internet. That's always a good sign. Boink. Run it. Actually, I want to go real quickly. I want to go Control A. And I just want to do SY. Boink. Blind send. Let's go, baby. Surely what Ari sent me wouldn't have any issues at all. Let's see. This package is located between there. Use the Vulkan SDK. Oh wait, you know what I can do is I think I can just do which Vulkan-SDK I think will return. Vulkan SDK not found. Awesome. I might need to source my ZSH file again, so let's just try that.
You should see a Vulkan SDK
In my user folder again.
In your zip folder, yeah.
Cool. Let's do that then. Whoop, I did that wrong. USR. Oh my god, I did that wrong again.
So if you go to the download the SDK and then install the SDK chapter, is like you should see the stuff that you want to do.
Sorry, you said we're looking for a what file now? Because I'm stupid.
So you kind of downloaded the stuff if you want to build it. So you want to get to the use the Vulkan SDK section of the getting started menu.
I see.
So a little bit far down.
Oh no, I'm
a little bit
right
far down. Yeah, right where you're at.
Okay, let's do that then. I will. Let's see. So let's see. CD to the left. Let's see. Make directory. Holy shit. Vulkan. Bam. CD to the / Vulkan. Bam. Yeah, sure. What all that does. I know all of that definitely. You see? Oh, because I didn't download the thing there. I see. So what I want to do instead is I want to go very quickly to my home to my. Where the heck is the Vulkan? There it is. Vulkan. And then I want to go up one. I want to go grab the Vulkan SDK, which is. That's the memory allocator. Do I not have it here? I thought it was here. Excuse me? I guess it got uncompressed and then ignored. So I'll copy here just to be safe, and then whatever. Okay, and then let's see. So we did. Oh no, I gotta probably run that command again. Ha 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 ha. I just realized this is no longer a tarball. So yeah, no, it's not a tarball. Okay. I gotta re-download the tarball. I think. Nope, it's right there. I don't know. Oh, because of my downloads folder. So I'm fucking stupid. Here, where's Vulkan? Vulkan. Sniff. Boink, boink. There we are. Boink. No file directory. Okay, I'm gonna go very quickly back. Okay, so I do not know what this command is running. I know that this is an encryption, and then this to me looks like it's trying to do a frickin' path, but that's all that I know. So, what I could do instead is I could just search for Vulkan. That seems to be my version. Yeah, so yeah, I just didn't update the fucking number because I'm a fucking genius. I'm fucking goated. I was skimming the command every time, so it's like, oh yeah. Let's see. So I thought it would have extracted something. I don't know what this command is running. This to me just looks like an encryption thing.
Which one?
It's the SHA 256
Oh yeah, that's just to verify the integrity of the file.
Yes. As you can tell, I'm a master with encryption. I am a fucking wizard.
It pretty much just makes sure that the file didn't get compromised or damaged during transit. That's all it means.
This is a Linux install. We don't care about none of that. Let's see. So I just want to go like that. Command A, bam. I completely forgot what it was. I'm like, I don't think it's password protected, but sure. Do your thing. I believe in you. Okay, there's that. Arch Linux, that please. Yes, Sir E. Bobbert. Oh shit, I forgot to control that. The shift paste always bothers me. It's ugh. I know I can rebind it, but like at the same time, no. Error target not found that. Oh, because I had a little nyeh at the end of it. There we are. Haha. Okay, so there's that. File contents. Use the source command to load your script, to load the script on the current shell. Okay, so very quickly I just gotta go, whoops. Let's close Kate. We don't really need Kate. So we just gotta do source, bang, vulkan, one dot, whatever the fuck, setup dot environment dot sh. Cool, that's done. Alternatively, you can set your path by setting these environment variables yourself. Nope, fuck that. Copying SDK files to system directories. If you want the SDK files in your system directories, here are some examples to do. Note some paths can be different depending on what Linux distro you use. Yep, so I don't think I'll fuck with that for now because I don't really care. So just verify the installation with whatever the fuck those commands were. VK via. Awesome. Oh wait, I didn't run the source command. Rip. I thought I ran it. Didn't I run it? Didn't I run the source command? Am I absolutely tripping nuts? Holy shit. Oh, scroll isn't even working. That's weird. I could just run around the source. Oh no, wait. No, I ran in the other terminal. These are other terminal instances. VK via. Oh, still not sourced. That's awesome. Uninstalling the SDK. I don't care about that. Okay, maybe I do have to add the header files. I don't want to because fucking sourcing the thing always bothers me. Okay. Yeah, you know what? Fuck it. Let's just get it over with. Envim. Whoops. I keep doing that typo. God damn it. Envim. Actually, no. I'm just gonna do this. Alias. Let's see. Vim equals envim. I think is what it is. Bad assignment. Vim. No, I don't want to change that. Alright, whatever. That's something that'd be quick, but apparently not. Oh no, fuck, I forgot that one up too. I need to go instead. I need to go to new or envim. Then I want to do my home directory dot zshrc. Bam, go away. And then now I just need to add a few other things. So I just need to add those, I believe. No. Header files, Vulkan SDK dot include, Vulkan user local include. No. Okay. So I missed a step here. Okay, so extract that, did that. Yeah, ran this one right here. File contents are all that. System file locations. Through their styles of possible, these directories will contain one or more Vulkan driver, JSON manifest, which are not modified by the SDK installer. Refer to the Vulkan loader guide. Okay. Set up the runtime environment, environment variable path, dynamic loader library, only SDK layer manifest. Okay. VK layer pass, set the system layer pass. Okay. So I ran the source, which is what is bothering me right now. Because I'll go back, or just do Control R for this source. Yeah, I ran the setup environment, right? So that's not happy. Alternatively, you can set your path by using these environments yourself instead. I don't. Welcome to Square SDK equals. No, okay, never mind. No. Okay, yeah, that's the command that I want. Give that a quick yank. Give that a quick paste. Ooh, that was not a paste, that was a copy. Okay, so very quickly, I just gotta go sneak on back a little bit. Don't mind me. Oh, wait, I'm fucking stupid. I got. Oh! Okay, so I just gotta go back to the envim zshrc, ignore you, because ignoring you is the best of times, so not that. I want to go that. Whoops, there we are. and then just very quickly I swap that for whatever the number is. So if I just go the best command in NeoVim sex, followed by a terminal, I am just looking for the version, which is going to be that. Whoops. Isn't it? Oh, no, sorry. It's I got to go command \n. I got to do control W down. There we are. I forgot the command for a second. I apologize. Whoops. Just go away volume. So we're doing 1.4.313.0. That all makes sense. I think that adds up, so we can save you, quit you, and then one more time try do the source on this, I think, maybe, possibly. Source spam, and then now time for the test VK via. I might need to reboot this, so let's just try hit it with a reboot and see what happens. Reboot. I know sometimes the header files are very picky if you don't like restart, so that could be potentially it. Can I say like one of the biggest piss-offs that I've seen the Linux community like perpetuate is like, oh, you don't need to restart your system ever. Like, what?
What?
Yeah, have you not heard that? Like people are like, oh yeah, you basically never need to restart your system. It's just like, excuse me?
No, that like if you update the fucking kernel headers and body like every now and then, you're gonna have to restart.
Yeah, like it's
like
that
just off of like by the design alone, it's like yeah, you're gonna have to restart, right? But
like I can definitely concede that like yeah, sure, it's probably less than Windows, but I mean like fucking when you're comparing the standard to dog shit, it's like maybe. Okay, let's see. Your fancy little glass overlay, KD. Come on. I believe in you. You can do it. There we are. Okay, let's see. Go away. You're interrupting my flow. Console. Whoops. VK via still not found. Oh, that's awesome. Hello. Dude, fucking source header files and shit are the fucking bane of my existence. Holy shit. I just always seem to have issues with them. I don't know why. Okay, so learn OpenGL. You know what, screw it. I'll pin this for later to have a little glance over it. But anyways, okay, so we were on building the project. We were there. It was right here, wasn't it? Yeah. So we'll do frickin'... We'll just detach this, go away. Go over here. We'll make you fat. I said fat. There we are. Beautiful. Okay, so where were we at? So let's see. We did the Arch Linux thing, we extracted it. These are the Vulkan major version, these are the Vulkan minor version, XX is the patch, yeah, that makes sense. Vulkan instance, each physical device has an API version. Download the SDK. We did the SDK. The Vulkan SDK installation persistent directed driver is extracted in the form of that. Yep, did that. Create a work directory. Did that. Did check something. I extracted using that command. Install runtime dependencies is not installed. I ran that. Let's see. Maybe because I'm on Arch or Manjaro, maybe some of the things aren't included. That makes no fucking sense to me, but let's just try it. So we'll just do frickin' sudo pacman-sy, and I'm looking for what is it? libxcb dash x input 0. I'm just gonna copy this one here because I know I ran the one at the bottom. No, I don't want to copy the URL. Whoops. I just want to copy these just in case for some reason these aren't added to the frickin' thing for whatever reason, you know? Whoops, that's not what I wanted to run. You can go back to right here. Blank. Not found any of those. Okay, cool. I can't say I didn't try it. Okay, so... I'll rerun this as well, just to make sure that these are installed. That's the wrong key. Whoops. Oh, I didn't install this. Maybe that might have been an issue. I thought I ran that, but apparently not, I guess. Whoops. Fucking butcher. Holy shit. Source. No, I don't want that one. I want the other one. That one. Go. Okay, alternatively, no, that's alternatively. Can I see variables? They're not permanently set up. I don't care about that. That's fine. Copying the SDK files to system directories. If you want the SDK, I don't care about that for now. I'm trying to get this to run. VK via. Via. Still not found. Okay, let's try Vulkan info. Vulkan info. Whoop. Vulkan info. I got Vulkan info. I got, I think, Vulkan. Which Vulkan? Vulkan not found. It's apparently fine, but it's not. Okay, that's cool. Well, Vulkan fucking runs. VK Cube runs. Is VK via at all necessary, or is that just being silly for me for whatever reason?
Verify the installation of the OpenSSD.
Like, I don't think so.
Let me check VKB on my end, but you should. That should still work. Yeah, it should. SDK found will attempt to run tests, attempting to run VK Cuban. Yeah, it should run some stuff, yeah.
Cool, I'm not getting it.
The
other two run.
LS for me. Actually, do an LS for me. I want to see you.
Stuck. I mean, you probably want me to go into the directory. One dot whatever the fuck there.
What the fuck is that? Open SDK thing.
Whoops. Invim. To the /.
If you want to build any of the repositories using the. Oh, nope.
VK via not found. God, what's the recursive search again? Like grep or something, isn't it?
Oh, I can't remember.
Cursive. Search Linux terminal. Oh my god, holy shit, there's literally a pop-up in each corner there. Look at that.
Jesus Christ.
Google pop-up, speech synthesis, cookies, try chat. Holy fuck. Alright, let's try this instead. So let's do this. So
yeah,
whoops, find tilde dash type d dash name vk via dash print. Nothing found. And then just as a sandy check, vk cube. Oh, nothing for vk cube either. You're starting directory. Oh, I should change that to frickin' this. Don't I need to add a dash R? I don't think this is. I don't think find is the good one. I could have sworn.
So you have. So you have decompressed the tar. You've downloaded libxcb, Zerma, and all of that, right?
Yeah, so what I did was, so I went to right here and I just literally just downloaded the SDK installer. I didn't touch the config, but it looks like a just JSON file, so that doesn't seem like it matters.
Then we gotta set up the runtime environment. Before you install the Vulkan SDK in the location of your choice, you need the set environment variables to locate the SDK components. These variables are identified in the table below. The SDK environment is set to the platform-specific directory. In your SDK installation. The rest of the variables are set using paths relative to Vulkan SDK.
Yeah, so I think you're on this line. Where was it? I think it's up here. You're like right here, if I'm correct.
Yep.
Yeah.
I'm looking at the install the SDK stuff just so.
Yeah, so if we very quickly, if I just do, what would it be, like echo tilde / dot zsh rc, oh no, that should be forward tilde, and then it also needs to be rc, not echo, fucking what am I thinking, cat, meow.
Yep.
Oh.
Meow.
There we are. So you can see right here, I have that in my ZSH, and that's after a restart, so it should be golden, right? Oh fuck! God damn it! I see.
What?
If you
Oh no.
Do you see the issue?
Hold up. Okay.
Yep.
313.
Hey, that's pretty good.
Yeah. So for context, I have this minor issue where once in a very rare while my keyboard will double click. And I just miss it, and that is one of those instances. Huzzah! Let's see. Source tilde / dot zshrc. Oh my god, that's not what I wanted. Zshrc bam vk via. Okay. Do I wish to restart? Would restart help? Reboot. Fuck it. Let's go for it. This will be my safety test. If this doesn't work, then I'm just gonna assume foot gunned. Whoops. You know, the setup's kind of dope because you can actually see my system restarting. It's kind of cool.
Yeah, you're just doing. I'm assuming that's a virtual machine.
No,
inside your Mac.
no, it's a capture card.
Oh.
Yeah, so this is all running on like native hardware because there's no fucking way I'm dealing with Vulkan on a fucking emulated system. Oh, oh, I would want to die. But yeah, no. So
I'm surprised in that restarting your machine doesn't cut everything out.
yeah, right. Well, no, okay. So TLDR is my MacBook is like my workhorse, right? It is the thing that I leave as like minimally configured as possible, right? And it's what I do like basically everything on. So it's like where I do my work, it's where I do my streaming, it's where I do everything, right? And then what I have is I have actually 3 systems directly behind me. If you can hear this little tinking, this is me like hitting it with a pen. It's like it's about a knee-high server rack. I don't know what the fuck would be. It's like 12 U's tall. It has an unraid server with like 14 terabytes of storage. My desktop, which dual boots Windows and Manjaro. And then a network switch that like I got it's like a fucking like company size network switch. Like it's like 48 ports that are supposed to run like a gig each. And I got the thing for like $100.
Nice.
Right. Yeah, so the one thing that I want to grab for it, which I don't have yet, is in the back of it I have a standard power strip literally fucking zip tied to the frame. I would really like to get like just like a server power supply that like, you know, is proper. But hey, hopes and dreams when I hit the big leagues. Let's see. So let's try VK Via. Still not found. VK Cube still runs. And then whatever the other one was. Vulkan. Oh no, that's just the file. Never mind. Yeah. So I wouldn't want Vulkan. I would want Vulkan. What was the test for it? Vulkan something or other?
BKV?
No, Vulkan info. There we are. Vulkan,
Vulkan
info. Both of these commands run. Whoops. Hello. Both of these commands run, but VKVI is not found. And I think if we search for it, grep recursive search, grep-r. So if we do here, we do grep space -r VK via. Is it running? There we are. I hit enter twice there, if you heard. Nothing found. If I search for VK Cube... Multiple VK Cube. I literally do not have VK Via. Isn't this a bitch? Oops. Let's try. Just // go away. Bam. Nope. Lib. Via. No. Cube. No.
Trying to find.
Cube. Yep, there's VK cube. So my guess would be that VK via would mean the same one. VK via. Nope, nothing. That's neat.
Yeah. I gotta go away for about a minute.
All good. What I might do is I might just go to the VK via, like just download the what do you call it? The actually wait, you know what? I just realized. Maybe there is a Vulkan tools. I'll let you step away. Don't let me hold you here. I'm gonna go Yakuin. What if I do, let's see, sudo pacman -sy, oh no, I want to do, qs, Vulkan tools, nothing, okay, no, because it's only drivers, right? Yeah. Oh, there's a Vulkan tools. Vulkan tools and utilities. Okay, where's that? Local. Oh no, maybe that's just. Oh no, that's because it's the like search history. Okay, so then I should be able to do that like sy Vulkan -tools. Yeah, do that. VK via. VK cube. Well, that's still working, so I don't know what the fuck to make out of this. This is no longer... Okay, there's... I thought it wasn't running for a second. I'm like, did we break it further? Okay, let's see. I love a recursive link. A tool that can do that, do that, do that. Okay, yeah, building, Vulkan tools, GitHub repository. How to generate the code, script generate, blah, 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 for example, debug release or that. CMake helper. Helper CMake does, I'll provide in the indication of that. Okay, remove tools. Okay, so what if I just go frickin' code, download the zip because I'm cool like that, open up the tools, then we'll open up the frickin' Vulkan directory that I made, Vulkan, and then we'll go to here, we'll go Vulkan tools, we'll just drag you over here, move here, we'll extract you, ta-da. Did you extract? I actually don't know. You didn't. Okay. Open with arc. Extract to not here. I want to extract to here. Extract to yeah. VK-tools. You're right. It can't be found. I just want to extract it to like here. Where do we extract? Cool. Did you work though is the question. Okay, did. Okay, so then I should be able to, I think, knowing basic compiler commands, go into cd // vk-tools, or no, vulkantools.main, ls. Okay, and I think it told me that they're including a CMake thing, and I heard CMake is either amazing or dogwar, depending on where the fuck you're at.
It is both.
Yeah.
It is dog shit, but there's really it's kind of the best tool for the job at the same time.
Yeah, fair enough. CMake error at CMake less cannot find package with any valid thing. Valid JSON config.cmake. Oh, that's awesome. Add the installation prefix of value that is, okay, well, I don't know what the fuck that is. Time for a quick Google. Ha ha ha. Validation is header only JSON schema that validates. A validation library for modern C++. Surprise that. It's configured. Okay. Validation only header. Okay, I'm not. I know like nothing about CMake. So this really doesn't make sense for me. So it's telling me that there's something wrong, yay, but like what do I do about this? Let's see, Vulkan tools, CMake. Oh no, sorry, it wasn't CMake, it was the other thing. It was the frickin' validation of CMake, missing. That was a typo. I'm not reading the AI answer because that's dog shit. Hey, guess what? I'm not AI. 4 pop-ups again. Love it.
Okay, so it looks like there are steps to building it. So let's see.
Here.
Note that sourcing the setup environment.h script or running export commands only set the environment variables for your current shell session. They do not permanently set up any of this configuration. For other shell sessions or computer logins, if you desire these to be set up for your future, consult your shell or desktop graphical environment documentation for instructions how to configure your system. For example, on most Ubuntu profile systems, adding a line to your .profile file to the source sets up the environment variables for you for both shells and programs started from the. This should make the lovely.
Oh, another Arch user is missing the package here. Let's see. If I was looking for an older package, I believe Arch used to provide that since has long been depreciated. This error should be thrown since this package is no longer provided. There might be a problem with VKVI on Arch. If it's not catch this error, we'll look further into this. This was 6 years ago. Does VKVI produce a VKVI HTML folder?
You ran the source command, right? Source /vulkan/ setup environment.sh, right?
Well, it's now my source file. So if I go like here, I go .zshrc, or no, I need cat. Cat meow zshrc, and we fucking do that. You can see right here, it's in my source file, right? Which, as far as I know, implicitly runs on startup.
No, there's a command called source that you need to run.
Oh, I ran that before, but I can easily find it. Source, which one was it again?
It was source and then ~vulkan, or ~vulkan/ your current version /setup -environment.sh.
Boink!
VKVia.
No. Nope.
Let's see. Of course, you would replace copying SDK files to system directories. The binaries include are built above them. Hold on, let me double check something.
Sure.
Is
Don't worry, header files are like my fucking bane. They always just seem to cause issues.
in SDK links. Then Turbo.
well, it's integrated with my system, so I can see all my Vulkan information right here in the info center, but...
And can you run Vulkan Caps Viewer?
What was it? Sorry, Vulkan, Caps Viewer?
Yep.
Yeah. Oh, wait, Caps, Viewer. Bam. That one works. Got a little dialogue and everything.
Okay. And then vkconfig-GUI is the name of the other command.
vk config-GUI. vk, I might have spelled that wrong. Config-GUI. That one's not found. Oh no, sorry, I said Vulkan. Vk config-GUI. That one's already green, so I'm guessing that one's gonna work.
Yeah, I'm looking at the.
Yeah, that one works.
I'm looking at the SDK stuff, and yeah, you don't have.
Like I grep for it, right? Like it's just not there.
Yeah, you actually don't have it, yeah.
And we verified the install too. Like we know the download's good. It was verified good. Like I don't know what more to say, man. Like like this is the biggest thing that always like is my biggest walls whenever I run into anything, right? Because I just sit here and it's like, oh, this thing that's supposed to be included just wasn't included and it's a fucking download. Like, what?
Yeah, there's no way to fucking. What the fuck? I do not understand.
Did I dox myself here? Nope. Cool.
Okay, so you got the Vulkan.
Isn't it confusing how I have like everything but VK info?
Yeah, the fact that you got everything by VKV is fucking weird as hell.
Yeah. And again, we verified it. Like, when was this last written? Is there like a source date on it? Nope, I'm not seeing a date. Maybe it's in like the metadata, like of the HTML. Whoops. Blink. Where is the head? Head, there's some markdown. Not seeing any publication info. No footer, nothing. Cool. Hell yeah. So we can't even verify this information's like hell out of date. I mean, I don't know. I mean, like, we got everything else. Say fuck it and push forward, I guess.
Yeah, just table it, I guess.
Yeah, I mean, if we run into something, then we can blame this, and I can blame Vulkan and upload my video and get like 4 views and have everybody tell me I did it wrong at step 4 when I didn't include a fucking semicolon or something, and then fucking I don't know.
Yeah.
Let's see. This is where we're at, right? Yeah. Start by getting that. Old chapters on the branch. Yeah, we did that already. I should probably just go to cd // test. That's a thing. Yep. Why are you doing? Oh, because you're down there. I see what's going on here. Don't you think you're tricksy? I don't know why that's running like that, but sure. Let's see. Let's do cd // test because that's where we're at. Bam. ls. Yep. Good enough. Let's see. So starting point. We did that. We grabbed CMake already because if I do CMake -- version. Ooh, kinky son of a bitch. Let's see, this one contains development headers. Yeah, we got that. We got CMake. What's installed? Use CMake-GUI. Ooh. I didn't know CMake has a GUI. CMake-GUI. Is that CMake-GUI? CMake-GUI? Yeah, that isn't a thing. Okay. Sudo pacman-sy CMake-GUI. Password is that thing. Nothing found. Cool. Awesome. I don't really care about the GUI, honestly. If at this point it complains about not finding Vulkan to... Okay, well, it's telling me to... Okay. Let's see. Let's see. CMake-GUI Manjaro. You can understand how to do it. And you're... Sorry. Fucking seeing how do I do this and then immediately seeing the line any real C++ enthusiast. Sorry. Okay. Oh, sorry. Or welcome to dismantle the following statement. I didn't read that. I thought it was some dude about to go way too hard into like actually, and I was like, no fucking way.
There's a reason the stereotype exists, I guess.
Yeah, I thought that's what it was going to be, and I was about to lose my shit. CMake okay, CMake GUI, and these fuck it, we're gonna run this command. Let's go, baller. Whoops, baller. That did not copy for some reason. Less baller. Boink, dink, doink, boink. Bam. I got CMake GUI. CMake-GUI. Man, I love random capitalization. That throws me off. Woo! Okay. Where's the source code? The source code is in this, like, tilde / yeah, like right there. Or to build the binaries, we want that to be in our bin. So I just gotta do a new folder. Bin. Ta-da. Okay. Search it. I don't know what I'm searching for. They just throw me at CMake GUI and they're like, hey, yeah. Press the configure button. Okay, where's the configure? Configure. Press the configure button. At this point, if it complains about not finding that, or Vulkan Discord library, make sure that you're at it. No dependencies you set. Okay, I don't... I feel like I need a tutorial on this. I don't know if I'm supposed to okay. I don't know what Green Hill... I don't know what any of you are.
Are you trying to do it through the text editor? Oh, yeah.
It's telling me to do it this way, and the thing is I've never had any experience doing it this way, so I'm kind of just looking at this like... I think I'm doing okay! Cause...
Yeah, I can only watch because I have done it all through the terminal.
Yeah, that's kind of what I was expecting. Cause like, okay, like micro terminal rant. What I like about the terminal is like it's just like, oh yeah, do this command, expect this output. Do this command, expect this output. Right? When they hit like when they tell me hit configure, I don't know if I like what values I need to set here. Right? I don't know what I'm supposed to hit here. I don't know what I'm supposed to be using that. I don't know what things I'm supposed to hear these. And if I hit finish. Configuration project files may be invalid. Okay. Does not appear to okay, I got some error. Does not appear to contain CMake list.txt. Cool. What is any of this? From Visual Studio. Oh, I'm supposed to use Visual Studio. I see. Okay, let's try this then. Oh no, I should do flat. Ugh. Flatpak install Visual Studio. That is an incorrect command. Thank you for pointing that out. Boink. I don't know why I jumped to the end, but boink. Okay. My guess is not on here because Microsoft is being proprietary and shit. So Flatpak Visual Studio. No, I don't want Visual Code. Let's see. Visual. Oh my god. Visual Studio Linux. Visual Studio Code, community, free download. Yep. Is that an exe? That's a fucking exe. Thank you, Windows. Is there like alternative builds? Oh, it does only exist for Windows. Okay, so considering that it says that this is only for Windows, that's an amazing start point.
Check my Visual Studio Code.
I do have Visual Studio Code. If we go here, Visual Studio Code, I do have this, but I don't know if this is going to work. File was not found. That's reasonable. Let's open the thing. I don't give a single flying fuck about that. So if we go into Vulkan Guide starting point, can I just set this as like a new thing? Open containing folder? No, okay, that's not what I wanted. Can I do like open? No, I want to get rid of this and I want to reset to like a new point, right? File, open folder, I think, and then I can go instead into like test, starting point. Okay, that seems about right. I don't have any build options though, I don't think. Camera, yeah, there's a bunch of things there, but none of those. CMake list.txt. Wait, there was a CMake list.txt. Hold the fucking phone. Oh, you know what? I think I went one file too high. That might be the one issue that I'm at. Let's see. We're gonna go to a starting point instead. We're gonna go there.
Yeah, that might be.
Yeah. It's kind of one of those things where it is like there is some subtle things that are implied, not told, and it's like, oh yeah, you know what? Like, I get that's a me issue, but at the same time, it is a tutorial, right? So, finish. User.ghs does not exist. I think it does. Which GHS file not found. Okay. Let's see. Sudo pacman -sy GHS. No, it's gish. I do not want the pistol. I want the other thing. GHS. Not found. Okay. What the fuck is a GHS? GHS. I'm not looking for the fucking data standard. Linux will probably be the best result. Multi-video. Oh, because I probably have the wrong. Because when I was going to here, I didn't know what fucking GHS was. So it probably has the wrong configurator installed. Yeah, I got that. Cancel. Build will go there. Environment, don't care. So I can't reconfigure because I selected the wrong thing because I didn't understand what it was asking me at first. If I configure again, no, I can't reconfigure. Okay. So if I can't reconfigure, can I instead go say maybe nvim // don't care. Starting point cmake list.txt. So I'm looking for a green something or other. Green something's not there. Okay, I don't know what I'm doing there. Third party. Cmake list.txt. Green. Grin. Green. Okay. Green. Nothing found there. Cool. SDL. See, the text for that was not like this is me like complaining real quickly, right? Like the text for this was not made clear to me, and then upon hitting configure, I can't change the current generator. Configure? Nope. Okay, gotta love having two buttons. How do I change the generator? That how do I change my generator? Can I change my generator? Mom.
Oh, you use Visual Studio to build the project.
Generator. Configure.
Oh,
That was
please put in a global location so you don't even worry about where it gets installed.
CMake GUI.
Well, not
Change configurator.
Finish installing the Vulkan SDK, then close and open CMake GUI, and then try configuring it here. Now that the dependencies are set, you can proceed with CMake and configure and generate project files with Visual Studio. Visual Studio, select the engine target and start project. I'm very fucking confused.
Right?
It's like, what are you missing?
Inventory? Oh! Fucking okay, no, okay. So my issue here is that fucking I went to like I didn't know what I was clicking on. When I hit configure, there's a dialogue that popped up that was like it looked like different terminals. I like, or not terminals, but like compilers, right? And I was like, man, none of these just say GCC or like G++, so I guess I'll just hit OK. And then I thought I'd be able to easily change it, and I apparently can't.
No.
So I deleted the cache. Let's try reopening. Okay. I want the source to be starting point. Okay. Configure. Here we are. Yeah. So see, I selected Green Hills Multi. Do I want Unix makes files? Do I want Ninja? Do I want Ninja multi-coding? Do I want Whatcom WMake? What the fuck do I want?
Oh god.
Yeah, right. You see where I'm confused? Because see, this is what's also throwing me off is that I see now Eclipse, Kate, and Sublime. So it's like, wait, is this like for an editor? I guess Unix make files and pray. I mean, I can just clear the cache again.
Hold up, let's see.
I mean, it's doing things now. It seems happier. It's going. It's chugging now. It's doing things. So maybe that's reassuring. I like seeing red.
You could probably just use like Ninja, but
I click.
why is it red?
I click configure again, and it suddenly was happy.
Oh, what was that red text?
Red text says, "Go fuck yourself," because it went away. CMake the pre-share version that third party is the CMake minimum required. Compatibility with CMake. Removed from a pre-share version of CMake. Well, good thing is we only care about this exact version right now. So pass as far as I'm concerned.
Okay.
There's one more above it. Oh, that's just the depreciation warning again. Okay, I think we're okay. Can we finally progress? Maybe. Okay, I think we're done with you. Okay, so managed to get that going. We got the third-party libraries. Okay, so it's also telling me to build via the GUI. I don't want to, but I guess I could. So isn't the command just like cmake-build?
Yeah, I believe it is CMake. Oh shit. I should fucking know, but I can't.
That's right, fucking exposing your lies and deceit to the internet. Wow. CMake
is CMake-S, and then for the source, and -B for the output building directory. That's what it was.
So CMake-S and then -B and then like tilde forwards or
-S and then the path of the source file. So that's probably just going to be like your current directory. So dot. And then -B is going to be the location of like the building directory that you want.
Path.
Does it give you I can't remember. Does it give you specific instructions? I went a completely different path from you, so I'm trying to figure this shit out.
You know what? It makes me feel much better knowing that even someone like you is dealing with my bullshit. Let's see. Ignore extra file. Does it want build instead of just -b? Build? Ooh, that's a caps lock. Oh my god, typos. Holy shit. That doesn't seem very... Does that show? Nope, okay. C make double dash help. Alright, where's the motherfucking dash B? Where's the dash B? Come on, dash B. Dash B. Oh, it's a capital B, god damn it. This is okay, like realistically, if you're not gonna separate like if you don't have like upper and lowercase like sensitivity, why not just fucking slam it? Oh shit, I'm in the wrong directory. CD folder slash options are going to be vulkan dash guide dash starting .2. There we are. Okay, and then we run the cmake command. Yay! Okay. Okay. We got the third-party libraries. I think we built the project. Is this supposed to be the end product that I built at the beginning? It actually didn't specify, I don't think. Okay. I guess I'll get the output of sniff and see what we got, and then go from there. So where the fuck is the build? The build is going to be in test. It's going to be in starting point, and then it's going to be in the bin, and it's going to be in the source, I'm guessing? Makefile? Maybe? Control A, bash, bam. It did a lot of things. Didn't do anything new, but it did a lot of things. Does CMake output to a source file? Like .src? Or /src?
CMake usually kind of outputs directly to a...
Then what the fuck did I just make?
Oh, did you just like run an install command?
It was just saying, hey, you can do the build thing. And I'm like, okay, cool. So I ran the build thing and nothing's building, so I don't know, because it's like...
Oh, you should just do like make. So it gave you a make file, right?
Yeah,
and then you need to run make. It seems.
Is it dash make? Double dash make?
Just make. It's just literally the command make.
That's fucking cringe. No target specify.
No, that's not the command is called make, not the option, the command.
I think you're trying to say delayed, like just make.
M-A-K-E, yes.
Yeah.
No, it's just M-A-K-E.
No, I ran that. If you look slightly up, I ran it right there.
Not the argument for CMake, just a command called make.
Yeah.
But it seems like that's not working either.
Make no target specified, no make file found. Stop.
Wait, hold up. Where the fuck was that make file that we just saw on your file explorer?
So there's a few. You see, there's the that. If it wants that specific thing, what I could do is I could do what is it? It's CD into the bin, and then I can do make here. Okay. I don't know nothing of CMake.
Oh, what the fuck?
So to clarify what happened is I ran fucking the CMake -s like the -s -b command, right? And then that output it into the bin directory, all of this stuff, which is apparently now running. Ooh, what error do we get? Oh, it's a pipewire error. Hell yeah. In function node that, Vulkan story port, audio pipewire STL3 error, passing argument 1, pipewire, node param enums from incompatible pointer type, dash win compatible pointer types. God fucking damn it, Windows!
Oh. Um. I don't know how to fix that, cause other than like going into the source code and casting it, but what the fuck?
So basically, TLDR is that whoever made this fucking tutorial made it hardcore Windows only.
Yeah.
Man, you know Vulkan, that cross-platform API that you wanted to learn? What if we made it in the Windows only tutorial?
I can give you another tutorial that'll be just good enough, but
I love bullshit. There is the legacy
it's
guide
kind of-
that might work. Nope, that uses also Windows bullshit.
I pushed it in for you in the DMs.
Hell yeah. Sorry,
Yeah.
sorry, you can like fucking acknowledge the irony of, oh wait, wrong link, I was looking one up. You can acknowledge the fucking irony of fucking you know, oh hey, this cross-platform API, what if we made it platform specific?
Is like what you make? Yeah, the fucking tutorial is
That is the biggest fucking horseshit I think I've experienced in a long time, actually. That is so fucking bad. I'm sorry, but whoever wrote that should unironically be ashamed. I know they said it was Windows focused, right? But I expected Windows focus in the way of like, oh, it's Windows focused in the way of like, you know, we're not, like we're going to write this for Windows users. So if you're not a Windows user, fill in the blank, right?
kind of what we mean by Windows focus, unfortunately, but oh well.
Yeah. Okay. Let's see.
I'm sorry, I didn't put two and two together.
I don't blame you in the
Yeah,
fucking slightest for that. Do not worry. That is okay. So for me, a beginner, that is a fundamental failure of both wording and your audience, right? Because on one hand, I understand Windows like is the fucking dominant force like 90%, right?
Yeah.
But that's
Yeah. It's
71.
Unfortunately, it says you
It's
will
actually
need to-
falling.
Oh yeah, it says the code in the project should work cross-platform, but this guide is Windows centric. We missed that. I am so sorry, dude.
But no, even then though, because Windows centric does not express to me Windows exclusive, right? You know what I mean?
Yeah.
Like that's bad wording, right? Like there should be like a warning that says like this only works on Windows, right? And like yeah, am I being a little pissy bitch about this? Yeah, a little bit, right? But like that's because it's like again, Vulkan is a thing which is directed to cross-platform people, right? What is the point of making a fucking project tutorial, whatever, for a cross-platform thing that is exclusive to one platform? That makes no fucking sense. That's that's like trying to sell shoes to fucking like a fucking like what do you call it?
Minotaur.
Yeah, I was gonna go a much darker direction of like saying like army vet amputees, like like the fucking like it doesn't work, right? But like that's just it's like frustrating for all of the wrong reasons. Okay. Ooh, ray tracing in one weekend. It's the weekend right now, baby. Even if this is a read book, there's an ebook. Okay.
What you doing, fat dog? You wanna go for a pee? You wanna go for a pee? I can go for a pee. That's okay.
Let me throw you outside. You can banish the shadow realm.
Ooh.
Sorry, my dog is like very chill because they'll just walk to the door and be like, "Hey, you know what I want? I know you know what I want."
Are you taking his ass out for a walk?
No, he just wanted to go for a piss. So I already walked him earlier, so he's all good. Okay, anyways. Okay, so very similar introduction, ebook, tutorial structure with stuff, an overview of how Vulkan works, And the work we'll have to do to get the first triangle on screen. The purpose of all the smaller steps to make more sense after you've understood the basic role in the screen. The basic role of the whole picture. Next, we'll set up a environment development with the Vulkan SDK and the GLM library for linear algebra operations and GLFW for window creation. The tutorial will cover how to set up these things up upon with Windows and Visual Studio Code and on Ubuntu Linux with GCC. Wow! See? Look at that. Cross-platform tutorial. Crazy that. Actually fucking which one was it? It was not you. I still had you open, didn't I? I thought I had you open. Maybe not. Maybe I'm tripping. All right, we're gonna pin you very quickly. Let's pin you. We'll drag you to the top. Let's see. I just want to make sure that other tutorial's fucking de-yeeted. Is it gone? Is it gone? Is it gone? Yeah, okay, that's all. Okay, yeah, good. It's gone. Pat.
So, usually the VK guide stuff usually kind of deals with like more advanced techniques that you might see like as you kind of like get into like more of actual game dev. So, hopefully the Vulkan tutorial will kind of like bootstrap your ass to like actually build something. But after a while, you might want to look at VK guide again.
That's fair. So. That's fair. I will approach it with much more caution next time, I guess. I will treat it as fucking landmine central. Let's make this a little bit bigger because this is a little bit small for people trying to watch and post. Okay, let's see. Let's see. Okay, we think we're a little bit up more. Okay, yeah, we did that. After that, we'll implement all the basic all the basic components of the Vulkan program that are necessary to render your first triangle. Each chapter will follow roughly the same structure. You know what's very funny? I just realized this tutorial this whole stream is probably going to be like 4 or 5 hours, right? And it's very funny because the first 3 hours are probably going to be timestamped as you can ignore all of this unless you're here to hang out. Let's see. Introduce a new concept and its purpose. Use all the relevant API calls to integrate your program or to integrate into your program. Abstract parts into helper functions. Although each chapter is written as a follow-up to the previous one, it is also possible to read these chapters as standalone articles, including a certain Vulkan feature. That means that the site is also useful as a reference. All Vulkan functions and types are linked to the specifications, so you can click them to learn more. Vulkan is a very new API, so there may be some shortcomings in the specification itself. You are encouraged to submit feedback to this Kronos repository. Wow, look at that! People actually know that they probably should do better. I like these people a lot more already. Dude. Tiny micro rant is like I know you said it's good, but being real as like somebody who's new to this, that makes me never want to click on like Vulkan guide again. Like just being real. Carrying on.
Yeah.
As mentioned before, the Vulkan API. No, actually, sorry. I'm thinking about this for 2 more seconds. Hold on, right? As the more advanced a developer gets, the less likely they are to be on Windows, right? Like, you know, like as a developer gets better, they'll generally migrate to like Mac OS or Linux, right? Sometimes.
Kind of.
Sometimes. Yeah. But from what I have seen and like sniffed, most people do that unless they beeline into game dev, right?
So in my automotive and other embedded jobs, we've pretty much done Windows inside a Linux machine. And then the Fang jobs, it was either Windows just straight up or Windows with a Linux virtual machine.
Yeah, but an asterisk there too, though, is I'm more referring to personal systems, right? As far as I'm aware, most people once they reach a certain developer status tend to lean on Linux or Mac OS. To be very clear, this is purely analytical from like what I've seen online, right? So this could be very wrong, but that's what I've seen, right? So I'm just sitting here thinking like wait a minute. So if you have developers who okay. On a scale of like 1 to 10, what would you rate the difficulty of like Vulkan? Like 1 being like hello world in HTML, and then 10 being like I don't know, fucking like writing fucking raw assembly to make Roller Coaster Tycoon.
I would probably. So it's like if I want to put OpenGL as a 5,
Sure.
I would probably put Vulkan at an 8.
Okay, so I'm diving right into the deep end,
8
right?
or 9. A little bit, yeah.
So, by that extent, the reason why it's frustrating, right, is because I'm thinking about this. So it's like, okay, people who want to learn Vulkan are probably inherently more advanced people, right?
Yep.
Which means that they are less likely to be on Windows. Which is
There's also the fact is like even despite the tutorial being like Windows centric with vkguide.dev, there's also the expectation that because they're a more advanced developer, they are more likely to be able, kind of like myself, I was more likely to actually kind of meander through and create my own environment setup to where I could actually follow VK Guide.
Yeah.
I completely forgot about the Windows centric part, and I failed to realize that would have impacted you.
Well, no, because even then too, I don't mind filling in some gas because to me again the whole idea of like Windows centric is like saying like able-bodied centric, right?
Yeah.
Where like if you tell me this building is able-bodied centric, I don't expect that building to then exclude handicapped people, right?
Yeah.
I just expect things like, okay, like, this building might not have like automated doors and shit, right? I don't expect every 3 feet to have a step,
Yeah.
I don't know. Maybe.
I mean, if you kind of like focus on, if it's like kind of centric, this might just be me, but I think that kind of implies it because if you're kind of like so focused on the natural steps that you would take to actually focus on the able-bodied, kind of naturally leads to designs that exclude the disabled.
True. There is definitely things like that, but like, I don't know. Again, because again, like just like by the definition of centric does mean like idealized towards, but not exclusive, right? That's why it bothers me because like words have meaning. I don't know. I might just be a petty bitch about this. I'm hurt. I'm stung. My little feelers. Okay, whatever. More reading, I suppose. Although each chapter is written as a follow-up to the previous one, it is also possible to read the chapters as standalone articles, including including a certain Vulkan feature. That means that the site is also useful as a reference. All the Vulkan functions are and types are linked in the specification, so you can click on them to learn more. Vulkan is a very new API. This must be old. So there's many shortcomings in the specification itself. You are encouraged to submit feedback to this repository. As mentioned before, the Vulkan API has a rather verbose API with many parameters to give you the maximum control over the graphics hardware. This causes basic operations like creating a texture to take a lot of steps that have to be repeated every time. Therefore, we'll be creating our own collection of helper functions throughout the tutorial. Fucking chef's kiss right there. Pardon, sorry?
Nothing.
Okay, cool. No, I mean like minor thing with this is the creating of the helper functions. This is something that I find is missing in a lot of tutorials, right? Because as somebody who's new, a lot of people don't know what a good abstraction looks like, right? So if you have like an inherently at least passable abstraction given to you, it's a lot better of a jumping off point, right? When by comparison, like if you're given just what's in the function and then you're told to abstract it, there's 101 ways to do that, which is just like, okay, that's cool.
And the fact that there's 101 ways to do it when it all kind of boils down to what your application is going to provide is kind of why the abstraction tutorials is kind of minimal. Like I kind of understand is like if you want like a good boilerplate for what like a decent abstraction of like the Vulkan stuff should be like, but there's also that fear that's actually kind of reproduced a little bit where the people who kind of like use the abstraction don't really mutate much and can actually be a bit harmful if they need to do something else that requires a different abstraction.
Well, I mean, like by like extension, like like I'm sure I'm going to turn Vulkan very close to something that's like OpenGL, right? Where like what my plan is that like once I get good with it, I'll have something that's similar to like like I'll do something probably like like alloc like texture, right?
Yeah.
And then it's like it'd basically then be like like file path, and then like and then like optional arguments here as like a dictionary or whatever I'll call it, right? Like I plan to make like allocations, or not allocations, but like functions like this, because that makes sense, right? Like I don't mind having to do that work, but it's like I remember there was this like one tutorial that showed me like the signal pattern, right? And I was kind of already aware of it mentally, but it's like, oh my god, like that just makes life so much easier. So yeah, I don't know, fun things. Let's see. Every chapter will also conclude with a link to the full code listing up to that point. You can refer to it if you have any doubts about the structure of the code. If you're dealing with a bug and want to compare, all the code files have been tested on graphics cards from multiple vendors to verify correctness. Each chapter is also each chapter also has a comment section at the end where you can ask any questions that are relevant to the specific subject matter. Please specify your platform, driver version, source code. Explain accept behavior and the actual behavior to help you. Yay! This tutorial is intended to be community first, to be a community effort. Vulkan is still a very new API. Best practices have not really been established yet. I'm guessing this is old. If you have any type of feedback on the tutorial...
it's been created about like almost a year after, and Vulkan is about 9 years old.
Vulkan release date. Yeah, that's reasonable. Okay, sorry. I didn't see the 2016 thing. I only saw the end, and I'm like, killing it, Google. But yeah, 2016 makes sense. Yeah, okay. Side question, if you know the history of it, is before then was Vulkan very like, or sorry, was there kind of already a Vulkan like solution, and then like that solution just broke down, or was Vulkan kind of like the first of its kind?
So AMD was creating a prior version of it. I want to say it's of the same. What the is called Mantle. So AMD was kind of like working on an API called Mantle, which was kind of like the new thing that was like supposed to like replace like DirectX and all of that, right? And over time, AMD kind of donated it to the Chronos.
Okay.
And that's kind of how it evolved to Vulkan, because the use case that they kind of wanted to have with Vulkan is a lot of the abstractions that we're kind of facing, especially with OpenGL, kind of go contrast with how the GPUs are actually like architected hardware-wise. So they wanted they wanted a framework that was much more consistent with how graphics cards work under the hood, right? Most of the time, right? Because they kind of change each generation, which is why it's not exactly a great idea to try and create like a big abstraction, unlike what you can with like on the CPU. Like each new generation, you can kind of create like a little, like tight abstraction, or you can like write assembly for it, and you just only have like that neat little box, right? But with GPU hardware, it changes almost each generation to the point where all the assembly, all the layout memories is going to be different. It's pretty damn foolish to try and create like an abstraction for each little piece of GPU hardware, which is why we went with Vulkan, for example. Because it's just enough abstraction to get like the work done while providing enough fine-tooth, like explicit control.
No, that's fair. Yeah, because like from what I've pieced together with you telling me about like the CUDA performance stuff combined with everything else I've observed, it's like it's one of those things where what I've sniffed so far is like, yeah, if you're building like an insane highly performant system, then like, yeah, you're not going to want to use Vulkan, you're going to want to use something like a CUDA, right? Which is like hyper specific, but at that point you are over optimizing. Well, not over optimizing, but like in any other industry, you would be considered to be over optimizing, right? Whereas Vulkan is from what I can sniff much more of a like capitalist like I'm trying to think of the best way to put this, like capitalist centric, where it's like, you know, you invest into a product, you use Vulkan for that product, and then that way you have the maximum customer reach, right? Like it's like you know, it's kind of like tailored versus mass market, right? Where CUDA's tailored, and then Vulkan is mass market.
Yeah, pretty much. Cause
Yeah.
yeah, because with Vulkan, it's like it was kind of a collective effort with all the companies to like avoid having their own standards, because kind of like what you said about it being like a little bit capitalist centric. It makes it much easier for the developers to write code for all the things that will pretty much work with any little GPU that is like compliant with that like graphics card, right? So there's a whole lot less development time required versus if you need like an API for each little vendor.
Which is also a lot more development time, and I would imagine with things like Linux and the vast amounts of hardware that would require, that would immediately make the project basically unfeasible. Also very, very, very side tangenty thing, but like I just have to express I love the furry branding Kronos Group has. just gotta share that real quickly.
Oh yeah. If I recall, the teapot, the rabbit, and the dragon are like staple like STL models that you would use for like graphics testing. I can't remember the fucking armadillo.
Yeah, I don't remember those three. I know the teapot, but the other ones I'm not familiar with. I think I've seen the dragon like one or two instances, but yeah, I dig it. I'm down with it. Nah, I don't know. All very interesting. I was looking for I was kind of glancing because I saw it's like, you know, it's like 150 or sorry, like 170 like companies like invested or whatever, right? And I was just curious because sometimes it's very fun. About Kronos? Is that it? Organization? Does it show the members? Nope. Okay, I guess nobody gets street cred for supporting here. Anyways, yeah, just I don't know, fun thing. Yeah, I don't think I have anything else to add. But yeah, nice micro history. I'm sure I'm both being like, oh cool, they're engaging, while also being, oh my god, this shit is fucking annoying. Let's see. Yeah, anyways, I guess let's roll forward. Let's see. If you have any type of, yeah, okay, there's that. See, you can watch the repository to be notified of updates tutorial. After you've gone through the whole ritual of drawing your very first Vulkan Power Triangle on screen, we'll start by expanding the program to include our first linear transformers, textures, and 3D models. If you played with graphics APIs before, then you'll know there will be a lot of steps until the first geometry shows up on the screen. There are many of these initial steps in Vulkan, but you will see that each individual step is easy to understand and does not feel redundant. It is also important to keep in mind that once you have that boring-looking triangle, fully drawing 3D textured models does not take much extra work. And each step beyond that point is much more rewarding. Yeah, I would imagine that the triangle that you draw here is basically just like effectively just like a recursive function. So it's like for each triangle, calculate its, you know, properties and then output. So I imagine it is quite literally like, you know, like a one brick in a church type thing. So yeah, I don't know. I can see it. Let's see. If you encounter any problems with the following tutorial, then check our FAQ. Yeah, okay, so let's get ready. Okay, let's see. So we've kind of read the origin. Okay, let's see. Because I imagine this right here is going to be extremely similar to the other one that we read. What it takes to draw a triangle. Now we'll look at an overview of all the steps it takes to render a triangle in a well-behaved Vulkan program. All the concepts introduced here will be elaborated on the next chapters. This is to give you a big picture to relate all of the individual components to. Step 1, instance and physical device section. Yeah, so a Vulkan application starts by setting up the Vulkan API through VK instance. Instance is created by describing your application, and any VK Any API extension you'll be using. After creating the VK instance, you can query for Vulkan supported hardware and one or more selected, one or more VK physical devices to use for operations. You can query for params like VRAM size and device capabilities and select the desired devices. For example, to prefer using dedicated graphics cards. That makes sense. Actually, side thing, just because like I'm just swimming with questions. Is it common to have programs that take advantage of both like an iGPU and like a designated GPU in like a laptop, or is that pretty rare for the most part?
Certain applications. So the one that I'm using is I'm actually doing it myself with a video editor.
Neat.
So that way, because the IGPs and all that can actually dissect and do like video stuff at the same time that the discrete device can actually do video stuff, and I can just have the IGPs just send information to the discrete GPU for actual crunching.
Yeah, fair enough. Yeah, no, I'm just curious because I wasn't sure if there's like necessarily an issue with that, because I think Photoshop or like Premiere added a feature similar to that in like 2016 or 18 or somewhere around there, right? And I remember like a lot of people were like, oh my god, this is huge, right? Like it's such a performance win, like, you know, I can't switch off Adobe because of this. So like I was just curious like how common it was. Maybe at the time it was rare, but yeah, just a fun little thing, I guess. Yeah, so to the logical device and queue families. After selecting the right hardware device to use, you need to use create VK device logical device, where you describe more specifically with the VK physical device features you'll be using, like multi-viewport rendering and 64-bit floats. Is multi-viewport rendering like just like multi-monitor support?
Yeah.
Okay, cool. You also need to specify which queue families you would like to use. Most operations performed with Vulkan, like draw commands and memory operations, are asynchronously executed by submitting them to a VK queue. Queues are allocated from queue families, where each queue family supports a specific set of operations towards queues. For example, there could be significant queue families for graphics, computer memory, transfer operations. The ability of queue families could also be used to distinguish factor and physical form selection. It is possible for a device with Vulkan support to not offer any graphics functionality. However, all graphics cards with Vulkan support today will generally support all queue operations that we are interested in. I would hope so. Step 3, window surface and swap chain. Unless you're only interested in off-screen rendering, don't know where that would be applicable really outside of like a Blender render. You'll need to create a window to present rendered images to. Windows can be created with the native platform APIs or libraries like GLFW and SDL. We'll be using GLFW in this tutorial, but more about that in the next chapter. Okay, very quickly, I'm gonna go like this. We're gonna go frickin' sudo pacman-sy glfw. I don't know if it's installed, but fuck it, let's go for it. Yep, that's a little trick for later. We need two or more components to actually render a window surface, VK surface KHR, Chronos, and swap chain, VK swap chain, Chronos. Note the KHR postfix, which means that these objects are part of the Vulkan extension. I would touch of feedback is I would like to see that expressed as Chronos, because I really don't like random abbreviations. The Vulkan API itself is completely platform agnostic, which is why we need to use the standard WSI, Windows System Interface extension, to interact with the window manager. The service is a cross-platform abstraction over Windows to render to, and is generally instantiated by providing a reference to the native window handle, for example, HWND on Windows. Luckily, the GLFW library has a built-in function to deal with the platform-specific details of this. The swap chain is a collection of rendered targets. Its purpose is to ensure that the image that we're currently rendering is different from the one that is currently on screen. This is important to make sure that to make sure that only complete images are shown. Every time we want to draw a frame, we have to ask the swap chain to provide us with an image to render to. When we finish drawing the frame, the image is returned to the swap chain for it to be processed to the screen at that point. The number of render targets and conditions for presenting finished images to the screen depends on the present mode. Common present models are double buffering, vsync, and triple buffering. We'll look into these in the swap chain creation chapter. Let's see. Some platforms allow you to render directly to a display without interacting with any window. Matter through the vk_khr_display and vk_khr_display swap chain extensions. These allow you to create a surface that represents the entire screen and can be used to implement your own window manager, for example. So I'm just thinking here, if this is way too complicated, feel free to just be like skip or whatever. But so when it comes to the double buffering vsync, I understand like vsync can make a game feel worse, but doesn't so from what I've sniffed so far, wouldn't every game effectively have to have a double buffer to like run properly, like without like flickering or something, or am I like tripping?
You need at least 2 images.
Yeah, that's what I thought, because it's how...
What's kind of weird is double buffering isn't vsync. Double buffering just means that, you don't draw onto the image at the same time you're presenting. VSync is a separate issue where if you're presenting during a refresh rate, it's going to create like little horizontal lines.
Yeah, screen tearing.
Screen tearing, baby.
Yeah.
Those are solved. Those solve different solutions.
Yeah, that's
different problems.
That's what's very throwing me off there, and I just wanted a sanity check because I'm like, hold on, I'm.
Yeah, this there's problems with this tutorial.
Yeah, I mean, like, hey, I respect it, but man, that could definitely throw some people off. Let's see, step 4, image views and frame buffers. Draw. Okay. To draw an image acquired from the swap chain, we have to wrap it in a VK image view and VK frame buffer. An image view references a specific part of the image to be used, and a frame buffer references the images that are to be used for color depth and stencil targets. Because there would be many different images in the swap chain, we'll preemptively create an image view and frame buffer for each of them and select the right one at draw time. Step 5, render passes. Render passes in Vulkan describe the type of images that are used during rendering operations, how they will be used, and how their content should be treated. In our initial triangle application, we'll tell Vulkan that we want to render a single image as a color target, and that we want it to be cleared as a solid color right before the draw operation. Whereas a render pass only describes the type of images, a VK frame buffer automatically binds specific images to these slots. Also, I just realized as well is, let's see, old computer loading. I don't know if this will come up with a GIF, but I just want to see things. Okay, so I'm not sure if you have the visual of this in mind. I do, but like with old like CRT shit, I have this mental image of basically something like this, where the screen flashes back and starts loading like vertically, like top down. Would that effectively be like a single frame buffer, where like when you try to refresh the frame, it's like full refresh, like that? If you know what I'm talking about.
Pretty much. It's kind of like it's kind of like that, but yeah and no.
We can just leave it at that. We don't have to go too in depth.
Yeah.
This is that was just a morbidly curious thing, because I'm like, well, when you think about it, like, the computers back then might not have had enough memory for like double buffer, so like whole issue, right? Let's see, step 5, render passes. Render passes in Vulkan describe the type of images that are going to be used in the rendering operations, however they will be used, and their contents should be treated. Our initial target triangle application will tell Vulkan that we'll use a single image. No, we read that one already. Whoops. Graphics pipeline. The graphics pipeline in Vulkan is set up by creating a VK pipeline object. It describes the configurable state of the graphics card, like the viewport size and depth buffer operation, and the programmable state using VK shader module objects. The VK shader module objects are created from shader bytecode. The driver also needs to know which render targets will be used in the pipeline, which we specify by referencing the render pass. one of the most distinctive features of Vulkan compared to existing APIs is that almost all of the configuration of the graphics pipelines needs to be set in advance. That means that if you want to switch to a different shader or slightly change your next vertex layout, then you'll need to entirely recreate the graphics pipeline. That means that you'll have to create many VK pipeline objects in advance for all the different combinations you'll need for your rendering operations. Only some basic operations like viewport size and clear color can be changed dynamically. All of the state needs to be described explicitly. There's no default color blend state, for example. The good news is that because you're doing the equivalent of a head time compilation versus just in-time compilation, I believe JIT, there's more optimization opportunities, and for the driver and runtime performance is more predictable because large state changes like switching to different graphics pipelines are made very explicit. A small thing I was going to ask with this is so like with pre-compiled shaders, is it basically like every shader more or less gets like okay, like this is a very weird thing to try to express because I don't have like the proper like terminology for it, but like is it if you think of something like sine, right? We're like sine like as a function is kind of costly, but it can be graphed to a sine wave, right? Is it something where like a pre-compiled shader is basically like taking sine, compressing it to a sine wave, like, and then basically referencing that, or like, am I completely tripping off?
No. So when it's kind of pre-compiled, is that you all you have to do is just kind of load the code that's already like pretty much in bytecode.
Okay.
So if you don't have pre-compiled code, what you would have to do is you have to take the shading language file, and then you would have to compile it, like just-in-time compiling into bytecode, and then you would load it in.
Okay, fair enough.
So it's mostly about the fact that is like you can compile it ahead of time, and you can load it much faster rather than having to compile it each and every time.
Yeah. I guess the TLDR for anybody watching this in the future, because let's be real, nobody's watching this at this point.
There's 2 other people watching.
Neat. News to me. I'm mostly not looking at the viewer count, so I can't tell. But
That's fair enough, yeah.
But I mean, like, let's be real. I don't want to sit here with like being all pessimistic about being like, oh yeah, we're watching. Like, I don't know. You know, yeah. I don't want to turn off. Anyways, where was I going with this? So no, what I was gonna say is like to anybody watching this in the future, the way that I understand JIT compilation to work is effectively instead of having like a bunch of preset values that you look up, just in time compiled basically means like the computer has to figure it out on like the go, right? So if the average game is running at 60 FPS, that's roughly like 16.6 milliseconds, I think it is, between frames, right? Which effectively means whatever compilation your computer has to do, it has to calculate that within that 16 milliseconds, effectively, right? That's my understanding. Whereas with like a pre-compilation, it's more akin to like looking into like a table of values or something. That is the TLDR. So basically, if you think of restaurants, it would be like McDonald's, where like everything's basically pre-made and you just reheat it, versus like like some like bespoke restaurant. Because like this is the thing that always pisses me off. Actually, sorry, might make a rant about food, I guess, is that like it always bothers me how like people are like, oh, I'm going to McDonald's to save time. It's like, dude, if there's a lineup, you're saving no time at McDonald's. Like an actual restaurant that's competent will have your food out to you in like 5 minutes. Like I don't get people fucking worshiping McDonald's. It's not that fast. Anyways, yeah, let's see.
It's like it's not even that cheap too.
Oh yeah, no,
I mean,
like,
and the difference between like McDonald's and like a comparably better meal is only like $2 extra more. So get the better meal.
Okay, so this is like a micro rant thing, right? So McDonald's Canada, right? If we go fucking here, we go to like the fucking block you go away. So we go like the menu, right? And we go to like, let's say just like I would say a quarter pounder is like the average burger that most people probably get, right? Like quarter pounder with cheese, like that just kind of seems to be like the default burger, right? Oh, it doesn't show you the price. Okay. I just want to show you this in Canada. Because you will probably find this funny. Actually, no, here, let's do this. Large fries, McDonald's price Canada. Perfect. This is actually wrong. I have seen this as high as $7. For a large fry at McDonald's. $7 for a fry. Pre-sliced potato biscuit thing. What the fuck? For context, there's this other place. It's called Barburrito Vancouver, because I don't want to dox myself. Is the food looks like this, right? And you can get like a burrito like this for like $12, right? So it's like, for an extra fucking $5, do I want this or a fry? Like, oh, it's crazy. It's crazy. Anyways, let's fucking roll forward, because I'm burning too much time on this. One of the most distinctive, one of the most distinctive features of Vulkan compared to existing APIs that almost all the configuration of the graphic. Oh no, we did that one already. Yeah, okay, so we're on 7 now. Command pools and command buffers. As mentioned earlier, many of the operations in Vulkans that we want to exclude, like drawing operations, need to be submitted in the queue. These operations first need to be recorded into a VK command buffer before they can be submitted. These command buffers are allocated from the VK command pool, which is associated with, that is associated with a specific queue family. To draw a simple triangle, we need to record a command buffer with the following operations: begin the render pass, bind the graphics pipeline, draw 3 vertices, and the render pass. Because the image in the frame buffer depends on which specific image in the swap chain will give us, we need to record a command buffer for each possible image and select the right one at draw time. The alternative would be to record the command buffer again every frame, which is not as efficient. Step 8, the main loop. Now that drawing the commands have been wrapped into an initial command buffer, the main loop is quite straightforward. We first acquire an image from the swap chain with VK acquire next image Chronos. We then select the appropriate command buffer for the image and then execute it with VKQ submit. Finally, we return the image to the swap chain for presentation to the screen with VKQ present Chronos. Operations that are submitted to queues are executed asynchronously. Therefore, we have to use synchronization objects like semaphores to ensure the correct order of execution. Execution will draw the command buffer. Execution of the draw command buffer must be set up to wait on image acquisition to finish. Otherwise, it may occur that we start rendering an image that is still being read for presentation on the screen. The VKQ preset Chronos call needs to wait for rendering to be finished, for which we'll use a second semaphore that is signaled after rendering completes. Summary. This whirlwind tour should give you a basic understanding of the work ahead for drawing the first triangle, a real-world program that contains more steps, like allocating vertex buffers, creating uniform objects, and uploading texture images that will be covered in subsequent chapters. But first, we'll start simple because Vulkan is enough of a step of learning curve. Is enough of a steep learning curve that it is. Note that we'll cheat a little by initially embedding the vertex coordinates in the vertex shader instead of using a vertex buffer. That is because managing vertex buffers requires some familiarity with the command buffers first. So in short, to draw the first triangle, we need to create a VK instance, select the supported graphics card, create a VK device and queue to draw a simple presentation, create a window surface and swap chain, route the swap chain images to VK image view, create a render pass that specifies the render targets and usage, create frame buffers for the render pass, set up a graphics pipeline, allocate and record a command buffer with the draw command for every possible swap chain image, draw frames by acquiring images, not requiring. Submitting the right draw command to the buffer and returning images back to the swap chain. It's a lot of steps, but the purpose of each individual step will be made very simple and clear in the upcoming chapters. If you're confused about the relation of a single step compared to the whole program, I should refer back to this chapter. API concepts. If you're too stupid, try again. API concepts. This chapter will conclude the short overview of how the Vulkan API structure is lower level. Coding conventions, all the Vulkan functions, enumerations, and structures are defined in the vulkan.h header, which is included in the Vulkan SDK, developed by LunarG. Will be installed in the SDK in the next chapter. Okay, development enrollment. Yeah! Linux, baby! Vulkan packages. I think we got Vulkan-tools already. You ready for this nightmare again?
Oh.
Hell yeah. Let's see. Sudo apache.
Although because it's only like Ubuntu, it should still be very translatable.
Yeah, that's pretty much what
Sure.
I'm thinking. Vulkan-tools. I think that one doesn't exist on whatever. Oh, it does. Okay, cool. Whoops. No, my code. It's so perfect. Let's see. Command utilities most importantly, VK info and cube. Run these to confirm your machine records Vulkan. We got both of those running already. Hell yeah. Libvulkan.dev or sudo dnf. Well, good thing I'm on the Arch. Or sudo dnf install Vulkan loader devil installs the Vulkan loader. The loader looks at functions at in the driver at runtime, similar to GLEW for OpenGL if you're familiar with that. Oops, I guess I didn't copy it. Let's see. We're gonna do this one, copy, and then we're gonna do the sudo pacman thing again, but we're gonna do this one instead. Fuck. Boink, 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 boink. Not found. Libvulkan dev. Okay, that one didn't find anything. Vulkan-loader-devil. This is the devil, I tell you what. Cursed. Whoa, that is not what I wanted. I think I actually copied the link by doing the whole Control-Shift-C thing. Boink. All the hotkeys are scrambling my brain. Okay, I definitely hit you that time. What the fuck? Okay, I'm gonna try it one more time. If not, then I'm just gonna type it in manually. Okay, go, shoot. Go away. Why are you not focused? There, good. Holy shit. Okay, I don't know where it's gonna be. Vulkan Loader Devil, Mangaro. Navigating Vulkan Mangaro, I have okay, this seems like something else. What about libvulkan dev? That seems proper. Boink. Mangaro. Oh shit, Mangaro. Libvulkan control by default. Vulkan. Maybe it was included with another package. Okay, let's roll. Maybe it was included, but or bundle or some shit. I look so hard to if you're familiar with that. Vulkan validation layers. Let's try that one. Doink. Not found. Awesome. What was the other one? Spriv tools. Spriv tools. Not found. Okay, cool. Sudo dnf Mesa Vulkan Devil maybe instead. Blindly firing. You know, I'm gonna do that, and I'm gonna go like, yeah. Nothing found. Awesome. Vulkan validation layers. Devil. Oh nope, copied the wrong thing. Whoop. Boink. Doink. 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 Whoops. Let's do it one more time. There we are. Boink. Hey, look at that. Nothing found again. Oh, well, if only I read 5 seconds further. God damn it. Let's see here. Vulkan Devil. Yeah, default all, please. Yeah, hey, look, that was everything that I wanted. Cool. Read the paragraph first. If the installation was successful, you should be all set with the Vulkan portion. Remember to run VK-cube to ensure you see the following pop-up window. VK-cube. Oh, fuck. That's VK. VK-cube. Yay! Let it go. It's a happy little dude. We'll put that right there. That's where you live now. You're part of my family. If you receive an error message, ensure that all your devices are up to date, including the Vulkan runtime, and that your graphics card is supported. See the introduction chapter for link to drivers of the major versions. GLFW, as mentioned before, Vulkan itself is platform agnostic. API does not include tools for creating a window to display the rendered results. To benefit from the cross-platform advantages of Vulkan and to avoid the horrors of X11, oof, cutting deep. We'll use the GLFW library to create a window which supports Windows, Linux, and macOS. There are other libraries available for this purpose, like SDL, but the advantage of GLFW is that it also abstracts away some of the other platform-specific things like Vulkan besides just Windows creation. We'll be installing GLFW from the following command. Hey, let's do the Wayland one, because I think Wayland is now default. Heck yeah. I'm sorry, Cube, I must kill you. Wouldn't it be so sad if it, like, actually, like, fucking, like, cried on the way out? It's like, no!
Oh no.
Just make everybody feel bad, or you just see something which is like, I thought we were friends, with like a little crying face, but like text-based crying face, not like emoji, because emoji would just make me want to click it more. I think we got GLM already, but let's make sure we got Gloom installed. Gloom. Oh, I don't. Cool. Neat. Let's see, shader compiler. Unlike DirectX 12, Vulkan does not include a library for linear algebra operations. Okay, yes, that's what GLM is. I'm guessing it's like GNU library math. Probably not. OpenGL. So graphics library mathematics. Okay. Sorry, I hate abbreviations if I don't understand them. They bother me way too much. Let's see, shader compiler, we have just about everything we need except for we'll want a program to compile shaders from the human-readable GLSL to bytecode. Two proper shader compilers are the Chromosys group GLS Lang Validator and Google's GLSLC. I was not expecting Google to appear here, honestly. The latter has familiar GCC and Clang-like usage, so we'll go over that on Ubuntu. Download Google's unofficial binaries and copy GLSLB to know that you may need to sudo depending on your permissions. On Fedora, use sudo glf install. While on Arch, you can run that. Thank you, Arch nerds. Whoops, that's the wrong copy again. I'm so used to the terminal. Heck yeah, we run that shit. Shader or she? Oh, shader C. Shader C? Which shader C? I'm guessing it's just some header files. Or something. Oh no, GLSCS? Or was it SC? No, SLC. There we are. Bam. No input files. Haha! We'll cover the shaders module chapter. Okay, setting up a makefile project. Now that we have installed all the dependencies, we can set up a basic makefile project for the Vulkan and write a little bit of code to make sure that everything works. Create a new directory in a convenient location, name like Vulkan test. Fuck you, I'm using just test. Create a source file, named main.c++, and insert the following code. Don't worry about trying to understand it right now. We'll just make sure that you can compile and run Vulkan applications. I will start from scratch in the next chapter. Okay, so I'm going to go very quickly. I'm going to go cd / test / whatever. I'm going to make a directory which will be tilde / the _ cooler _ Vulkan _ tutorial. And we're going to cd into that, and then we're going to go just envim, I guess, into main.cpp. Don't care. Well, as I said, don't worry about it, so I'm not going to worry about it. I'm going to smile, nod. I'm going to eat my vegetables like a good little boy, and I am going to run unused variable test. Hey, I have syntax highlighting working? Hold on. Sorry. This is shocking. This isn't supposed to be running right now. I thought NeoVim wasn't supposed to work right now. I was expecting no syntax highlighting. Excuse me? I mean, I'll fucking take it. I'm down. Oh, I realized this terminal is probably a little bit hard to read. No, not there. Sure, good enough. Okay, and then let's see. What am I doing from here? I am then going to go. So we did all that. Next, we'll write a makefile to compile and run this basic Vulkan code. Create a new empty file called makefile. Okay. Let's see. Echo all of this right here. Quote that shit into makefile. ls Cool, that worked, I think. Let me just double check. I actually don't know if I did that right. What else? Cat make file. I don't use the. Hey, I did it. Cool. It's been so long since I used the echo command. I don't remember the syntax for it at all. That was pure instinct. We're going to use modern C++, dash standard 17. Oh, oh man. If only they didn't. Sorry, like two more versions later. We'll set an optimization level of O2. We can remove -O2 to compile programs faster, but we should remember to place it back for release builds. Similarly, define the linker flags with the LD flags variable. Okay. Let's see. We'll just go copy you. And then we'll go just freaking echo. Paste that shit in there, and then double dash into make file. Oh, that's capital M, please. Make file. Then we'll just cat it to make sure it's on there. Awesome. The flag that is for GLW. The dash Vulkan links the Vulkan. Links with the Vulkan function loader and the remaining flags or low-level system libraries that GLFW needs. The remaining flags are dependencies for GLFW itself. Defending window management system. Fair enough. It's possible that XFF68VM and Z libraries are not yet installed in your system. You can find them in your following packages. Yoink, 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 yoink. Thank you so much. Specifying the rule to compile Vulkan test is straightforward now. Make sure to use tabs for indentation instead of spaces. Fuck you. But valid. That is the proper thing to do. Thank you. Let's see. Specify the rule. Test. This is throwing me off. I don't understand. Is this supposed to be like a terminal argument, or is this supposed to go into the make file?
Hold up, let me double check. Specifying the rule to compile. That below code is makefile.
Okay. Yeah, I have once again no experience with makefile, so that is very much something that's throwing me off. So I would have guessed the makefile if I had to throw it, but I very much appreciate your hey dipshit. Let's see. We're gonna add more rules. Test clean. Clean the test after. Ooh, I say dangerous file. Ooh, scary. Let's see. Let's see. C flags, LD, Vulkan test, phony test clean. Cool. You can now use the directory as an example for your Vulkan projects. Make a copy, rename it something like hello triangle, and remove all the code in main.cpp. I'm sorry, what? You can now use the directory as a template for all your Vulkan projects. Make a copy and rename it something like that. You're now set for the real adventure. Okay, so if I do, let's just save and exit. So if I do something like this, and then I do say like this, and then I go, no, I want to go copy. I want to go copy the. No, sorry. What was the options? Oh no, I need to go CD into the parent directory, and I need a copy from the cooler Vulkan tutorial into frickin' I don't know, hello_try. I guess I need a -r. It's been a hot minute since I used the copy command as well. That worked. Okay, I'm happy. And then from here, I want to go back into. I think I want to try compile. From now on, you're all set for the real adventure. I'm guessing the real adventure is just going to be the next chapter, which is like drawing a triangle. Yep. Okay. Cool. Okay. So from here, I then want to go to the first thing, which is going to be. Sorry, I just want to go back into the cooler Vim tutorial, like that, and I want to try and make. I believe it is. Missing separator. CMake. No, it was like the CMake dash S, wasn't it? C. Oh no, it's like a dash S. No, dash E. So directly that does not appear to contain CMake. Okay, wait, I have no idea what I'm doing. I thought we were supposed to do a test compile, setting up Xcode. I don't care about that. I don't care about that. I thought we were supposed to do a test compile. Wasn't? Sorry, am I crazy? Didn't they say we're trying to do a test compile? I'm trying shits. Okay.
You're supposed to take the code down there and just do a test compile.
Do I just use like
So
G++?
Yeah, in the bottom of the page before the comments though, it should give you C++ code and
Yeah.
file shit for you to actually test.
Yeah, so no, so if we go up, this was the C++ code. Right here, for like the Linux environment. And then here's like the CMake flags. Oh, I completely missed the link to the tutorial. What do you make files exist? Okay, what alternatives are there? CMake, hello, that, okay, yep, cool, awesome, targets, prerequisites, essence of make, hello, okay. Blah.c, blah, okay, more quick examples, cool. I kind of understand the examples of it, I just don't understand how to run a CMake. Teach me your ways. Default shell, ooh, that's just a shell command, okay, I see. Oh, sorry. To be an absolute pain, what do I need to run to make CMake just do a thing? Premium to make file, yeah. C flag variables, yeah. How do I run you? You mentioned the make command before, but I don't think that's gonna work. Missing separator. What separator am I missing? Dash build? Nope. Let's see. CMake dash build. Nope. Okay. What the heck am I missing? Skim the thing. Let's see. Invalid that. Okay. Make options that. Ignore for compatibility. Okay. And does you make all? Sorry, unconditionally make all targets. Directory. Print debugging information. Environment overrides. Evaluate string. Print this message to exit. Ignore errors. Directory. Let's see. Allow and at once. Keep going when some targets can't be made. Max load. Let's see. Just starts multiple jobs unless below n. Use targets. Actually, use the in-time system. Don't automatically run. Consider file to be very old and don't remake it. Synchronize the output of parallel job types. Run no recipe. Disable built-in implicit rule and variable settings. Performance shuffle. Don't echo replies. Turns off -k, which is the keep going. Touch instead of remaking them. Print the version number and exit. Print the current directory. New file, assume new, consider file to be infinitely new, warn undefined upgrades, warn, okay. This program was built for x86 Linux. Okay, it's Google time. How to build a program with CMake. Is it just build? What is guild? I just want to see what guild is. What is guild? Run command line scripts provided by GNU Gili related programs. Commands. Complete a file. Disassemble the compiled .go file. Display the commentary section on file modules. Snarf out documentations from a file. I like the word snarf. Okay, I have no idea what it means, but sure. Show a brief help message. Use 2 dot. What? What is guild? What magical fairy thing is this? What? Hold on. GNU guild. What the fuck is GNU guild? Gilly is a programming language. Oh,
I just go back. What the fuck are you trying to do?
Okay, sorry. I'm trying to build a thing with CMake. I don't know how to build a CMake. I have like no experience with it, right? And then when trying to correct it, I saw I got an option for guild, and I'm like, what the heck is guild? And then I found out we got doc snarf.
Wait, what's this CMake about? Is this the Vulkan tutorial bullshit? Because
I just don't know how to make anything.
Hold up.
Build. Because if I run make, I get missing separator.
What the fuck do you mean missing separator from make? Wait, you're saying make has missing separator?
Yeah. So if I go like this, we ignore that. So we have my make file, right? And then there's all this. Maybe this is erroring. It thinks it's a space. Oh, is that it? If that's it, I'm gonna be upset. If that's it, I'm going to be very. Maybe it's all of them. Maybe I am tripping the balls. Okay, let's do that. Let's do that. Okay, that's.
Wait, what line was it?
It didn't say a line. It just said missing separate. Oh no, it did say it's 5. Make.
Okay, that's it. So yeah, that's probably all.
Okay. ls-a. I don't know why I did -a there. Let's see. / Vulkan test. Oh, did something break? Oh no! Oh no! That
Oh, are you using Wayland?
Probably.
If you are using no, you're not. You're not using Wayland. Looks like you're just using X11.
I think this is a compatibility fallback thing. I don't think I think I am using Wayland because I think by default Manjaro ships with Wayland now. Here I can do. I think if I go to what is it? It's log out. I think what I can do is I can do this. Hold on. This is one of them little Linux tricks. I think yeah. Oh no, I am using S11. Let's try Wayland. Fuck it.
Wayland will just not really draw almost anything until you actually draw something and present it to the screen.
Well, I was just using X11 apparently, so we'll try Wayland and maybe it's zesty. Maybe it's not. We'll see. We will compare. We'll point and laugh. Oh no. Side issue. I just gotta correct real quickly. I just gotta mirror the displays. Okay, so let's see. You are going to be a. Okay. You are going to be a mirror of the KVM, and then you are going to be a mirror of the KVM. Apply. Does this work? It's working on one display. Hey, look at that. Okay. Oh, I just realized I have the macOS like big cursor thing now. Where is it? Anyways, oh my god, that makes me feel like I'm using a crayon. Okay, let us try the console again. I'm just gonna pin this because you're gonna be living on my taskbar. EFG, HIJK. Why is that there? Yeah, I think you go there. And then you go like there. Yeah. Okay. What was the last command I ran? Let's first make you bigger. Hey, bigger. That may be a bit too big. Hold on. That's a touch too chunk. Okay, so then it was cd into the it's just gonna be tilde / it's gonna be test, I think. Yep, and that's gonna be the cooler Vulkan tutorial. Yep, and then we're doing it was just make, I believe. Oh, Vulkan test up to date. Okay, tilde / Vulkan test. Run it. 25 extensions supported. Huh? Maybe they don't want us to cheat. So in that case, I think it was right the first time. Then maybe. So sorry, I will ask this before I log out. Do you think I should be on X11 instead?
Probably for easiness, yeah, because
Cool.
Wayland kind of requires the service to be drawn before you can kind of do much of anything with it.
Fair enough. That's a native tutorial. Let's see. Well, at least we got to compile and we got to run. So that's a good sign, because that means progress. Did I tell you one of like the hyper annoying things I've like had to deal with on my website? With trying to play with my XOR encryption stuff.
Yeah, so you talked about the XOR encryption stuff just a little bit. Yeah.
Yeah, sorry. So here, I'll just share this real quickly. Is volbyte.com / secret / jwt_test. I think that's the link. No, fuck. I forget what it was. Fuck, what was it? Sorry. This is gonna take like 2 seconds. I just need to remember the website. It is. Oh, you know what it is? I didn't fucking sync it to my to my world. 1 second. Let's see. Remind me in 20 seconds to refresh this. But TLDR, there was a very funny, silly thing that I had to deal with. Let's see. C specification. Yeah, I don't care about that. That's my website. Try reload. No, fuck you. Anyways, okay, so we got those done now. Okay, introduction. We're now drawing the triangle. Woo! Progress. Let's go. Hold on. That's not what I want, Katie. There. Better. Okay, so let's see. Let's see. Basic code, general structure, resource management, integrating GLFW. General structure. Then the previous chapter, you created a Vulkan project with the proper configuration. Oh wait, I need to go to the wrong thing. So I need to go cd / test. Test. No, not templates. You stupid motherfucker. Test / hello try. We'll go to NVim. We'll get out of here. We'll go. Whoops. Oh no, this one has the old make file. I guess that's a good catch. We'll just go like that. Bap. 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 I forgot which one I wanted for a second. And then we'll go to makefile, and then not makefile. We'll go back into main. I'm curious if it has any highlighting. If it has highlighting, I will fucking screech in a good way. Pound include standard.io.h. It does not, but you know what? It gives me warnings, which is more than enough. I am very happy with that, actually. All right, moving on. General instruction. In the previous chapter, you created a Vulkan project with all the proper configurations and tested it with a sample code. In this chapter, we'll be starting from scratch with the following code. Okay, let's yank you. Sorry. Isn't it kind of funny how in Vim I can select all of the text faster than I can copy paste because of like awkward hotkey jankness? Sad. Let's see. Okay, so IO stream. I don't know what standard accept is. I'm guessing it's like an exception library for like warnings, and then C standard lib. Pardon, sorry.
Yep. STD accept is for error handling.
Cool. News to me. Okay, so class, hello triangle application, public void run. Is run in this instance effectively like what is it called? I forget the word that's escaping me, but like the like basically like when this object is created, do this.
Pretty much. It's
Okay.
so if you follow the code elsewhere, you can kind of see that
Oh, it
try
says
app.run.
Yeah. I'm stupid.
It will run that code.
Yeah. Sorry, no, it was constructor. That's the word. I'm unfamiliar with doing much classes.
Not
I thought it was...
really constructor.
No.
But
No, I see that now. I see my hubris.
no.
Hello Triangle application app. Let's just call them the class, yeah. And then we're naming it app, and then try app.run, catch constant standard exception that points to the address of E. I think that's how I read that at least. Standard which I'm guessing is cert or something like that. E dot what? Okay. Return exit failure, else return exit success. Okay. First, include the Vulkan header from the Lunar GSDK, which provides the functions. Sorry, actually, I'm gonna ask you about this now because this is one thing that's always thrown me off. Right? Doesn't this ampersand technically connect to this E here? Like it's asking for the address of this E.
Yeah, it's pretty much asking for a reference.
Okay, so it's asking for a reference to E. Okay, that
The difference between a reference to a pointer is you're still allowed to modify the contents of. Oh wait, no, because it's a constant reference. It basically kind of acts like a pointer, but just kind of makes it you're not allowed to like change the address of it. So it only kind of like points to E.
Okay, and then
So think of it like a Java like reference, if you've ever.
I honestly haven't. So what a simpler way to just read it would be exception is asking for the address of E. Is that just the way to read it?
So the type is a reference to to STD exception, and it's constant, meaning that you can't change the reference value that's pointing to.
Mm-hmm.
So you can't like change E to point to something else.
Yes.
And you can't actually no, you can't. You just can't modify the contents inside E. That's what it means.
Okay, yeah. And then the ampersand is the value, and then an asterisk would be the address, right? If I'm correct?
Pretty much.
Okay, cool. Just want to double check. Because it is, again, hot minute.
Yeah.
Cool. Sorry, it sounds like you're about to add something else, unless I'm tripping?
Yes, it's not exactly like of the value, but it's like if you don't know what a Java reference is, it's like a half powerful pointer.
Okay. Like a pointer, but it doesn't directly store the object's data. Instead, it holds in the memory address where the object is located. Okay, so...
Which is kind of weird because a pointer also just holds the memory address where the object is located. But when you kind of hit like with a pointer, type E. If you type in just E, it would be just like the address, right? Mm-hmm. But if you do star E, then it would point to the object, right?
Okay.
But if you do ampersand E, like there, that's a reference. It still kind of holds the memory address, but you don't really have to deal directly with the address in itself. So if you just do E dot whatever, it's just the value of E. You're no longer dealing with you just don't have to deal with dereferencing, as it's called.
Okay.
Which is fucking horrific naming.
Yeah, I think it's just one of those things where like I don't have the reps in to properly get it, because like I understand all those words together, right? It's just like the dots are not obviously connecting, right? So I think that's my main issue right now with that. Like you know, it's like hearing somebody talk about like a catalytic converter and like your 5, right? Where it's like, oh, you know, smoke goes into it, it reduces carbon and then out, and you're like, okay, yeah, I follow, but like, huh?
Yeah.
Yeah, anyways. Yeah, I guess we'll just keep going with it. We first include the Vulkan header from the Lunar SDK, which provides the functions, the structures, and enumerations. The standard except and IO stream headers are included for reporting and propagating errors. The C standard lib header provides the exit_success and exit failure macros. The program itself is wrapped into a class where we'll store the Vulkan objects as a private class, members, and add functions to iterate each one of them, which will be called from the init Vulkan function. Once everything has been prepared, we enter the main loop and start rendering frames. We'll fill the main loop function to include a loop that iterates until a new window is closed in a moment. Once the window is closed and main loop returns, we'll make sure to deallocate the resources we've used in the cleanup function. If any kind of fail error occurs during the execution, then we'll throw a standard runtime error exception with the descriptive message, which will propagate back to the main function and be printed to the command prompt. To handle a variety of standard exception types as well, we'll catch the more general standard exception. One example of an error that we'll deal with soon is finding out a certain required extension is not supported. Roughly every chapter that follows after this one will add one new function that will be called from init Vulkan, and one or more new Vulkan objects will to the private class members that need to be freed at the end of end in cleanup. Ow. Eh. I had like a canker sore like on my lips, so I would do like the pop lip thing, and it was like perfectly in line to like hit my teeth. It's like
Ooh.
Self-inflicted damage. It's like not bad at all. It's just one of those things like, God damn it. I forgot you were there until you weren't. Or were. Fuck. I don't know. Brain. Let's see. Resource management. Just like each chunk of memory allocated with malloc requires to call free, every Vulkan object that we create needs to be explicitly destroyed when we no longer need it. In C++, it's possible to perform automatic resource management using resource acquisition is initialization. Okay. Our smart pointer is provided in the memory header. However, I've chosen to to be explicit about allocation, deallocation of Vulkan objects in this tutorial. After all, Vulkan's niche is to be explicit about every operation to avoid mistakes. So it is good to be explicit about the lifetime of an object to learn how the API works. Yeah, fair enough. Sorry, quick side thing. Isn't a smart pointer, I've heard amazing and terrible things. Isn't a smart pointer basically just kind of like a standard variable in like a more like a low level language like JavaScript or something?
A smart pointer is a way to allow exclusivity to who can access a pointer.
Okay.
So you can have like a unique pointer where only like there's only like one ownership of it. Mm-hmm. And then you have a shared pointer where you allow like a certain number of people and you can actually track like who can actually like own it and all that. And once like every single like person has like deleted or removed ownership of the shared pointer, would that actually get deleted? Then you got like shared weak pointers and all that, where it allows for like smart allocation and management of pointers, so that way you can kind of get rid of problems like use after free or the like. Problem is it does kind of like require like you to like follow the rules that they have, because
yeah,
otherwise you're just gonna use like raw pointers. It's just like it's fucking useless.
Yeah. So sorry, are you like familiar with like Rust at all?
Tiny bit.
Tiny bit. So are you aware of like arc mutex, like atomic reference counting?
Ooh. Arc mutex? No.
Sorry. Okay. So like Rust arc. Arc, long story short, is it sounds very similar. This is why I was asking, because the way that it basically is so in Rust you don't really do memory management. You'll assign a variable, and then if you want to duplicate an object so the previous object can be destroyed or something like that, you do like arc mutex. Like I don't remember all of it, right? But like,
gotcha.
you basically mutex, which is basically cloning it or something. But each variable in Rust has a reference counter, right? So, like, yeah, you could not free memory unless like all of the explicit references to it have been like removed, right?
So that would be equivalent to a shared pointer then.
Yeah. Okay. So that sounds neat. For context, I was getting into Rust, but man, the syntax bothers me.
Hi, Physique, how you doing?
Yeah. Oh, sorry. I completely forgot to respond to them. I read them. I read that while you were explaining, and then I completely forgot about it because ADHD. But yeah, very fun. But anyways, yeah. Yeah, we're doing Rust, or not Rust. Fuck you, Ari. We're changing the fucking field. Nah, we're here we are. Sorry, so this is what I want to show you earlier too. I'll get to that in a second, but I'll jump back. What was it? No, we're trying to play around with Vulkan and making the magical Dorito triangle. Anyways, what I was going to say is so I'm a person who likes to hold state in the UI if it's like a you know, a user facing application, right? So for a while the XOR that's like right here, like the output, right? I was trying to store that here, and then I found out that like the registry like you know, it's like -r-n, right, or /r/n, you know, whatever. As it turns out in HTML, /r will get converted to -n implicitly. So I thought my dash, I thought my little basic ass XOR algorithm here was like broken, right? For the longest time, and I'm like, man, I'm really stupid. It's like, oh no, it's because JavaScript is doing some, like, JavaScript/HTML is doing some really stupid bullshit on me. It made me so upset to find that out. I was so upset to learn it was something so trivially simple, and it was just like, oh, I see, I was getting screwed over here. I fucking robbed. Anywho. Let's see. Yeah, I guess let's just keep rolling with it. Fucking, after following this tutorial, you can implement the automatic resource management, written by writing C++ classes that acquire Vulkan objects, and they're constructed and release them in their destructor, or by providing a custom deleter to either standard unique pointer or standard shared pointer, depending on your ownership requirements. Resource allocation is initialization. Is the recommended model for larger Vulkan programs, but for learning purposes, it's always good to know what's going on behind the scenes. Vulkan objects are either created directly with functions like vxCreate XXX, naughty, are created through another object with functions like vkallocate XXX. Okay, this article got very horny all of a sudden. After making sure that an object is no longer used anywhere, you can destroy it with the counterparts of vkdestroy XXX and vkfree XXX. These parameters are for functions generally, these functions generally vary for different types of objects, but there's one parameter that they all share. P-allocator. This is an optional parameter that allows you to specify callbacks for a custom memory allocator. We will ignore this parameter in the tutorial and always pass null pointer as an argument. Integrating GLFW. Vulkan works perfectly fine without creating a new window if you use it off screen, if you use it for off screen rendering. But it's a lot more exciting to actually show something. First, replace include with that. I'm not gonna replace. I think I'm just gonna swap it over. So let's just slam this out. Is that pretty short for the most part? Sorry, I just want to see. There we go. Okay, so oops, I think I actually pasted a line here. Yeah, there we go. So it is saying, oh, I pasted it twice. What? Okay. Yeah. So it wants me to clear out the Vulkan-H. So we'll comment that out and replace it with pound include. It was the GLSW one. What was that one again? Sorry. I'm fucking small brain right now. Did I scroll up here? Oh, that's a weird one. Wait, what? Am I losing my shit? Why did it feel like everything just jumped? Hold on, what? No, that's what I'm confused about, because I remember reading that, but now we're suddenly on GLFW. What happened? Base code. I know it wasn't very deep, but yeah, resource management, yeah. Integrated GLFW. Yes. No, I totally get that right now. I was so thrown off because this, I think, jumped like way lower or something, like the tutorial, right? So I got caught on like, this isn't where I am. Fucking grandfather dementia simulator. Whoops, Vulkan, and then we're doing pound include glfw /gl, oh my god, glfw3.h, kapow. Invalid pre-processing declarative. Oh, because I typed include wrong. That's very cool. That's the wrong command. There we are. Hey, look at that. The machine's suddenly happy. Let's see. That way GLFW will include some definitions, automatically load the Vulkan header with it, add an init window function, and add the call to it from the run function before the other calls. We'll use we'll use that function to initialize GLFW and create a window. Okay, so in that case, we're going to find run instead of init Vulkan. Oh no, we are including init Vulkan, but we're just adding init window. That's a wrong command. Unuse of the thing, and then in private we're doing one more, which would be void init. That's the space. Window. Oh my god, I'm typing so sloppy right now. Oh my god, this is fucking embarrassing. Holy shit. Good enough. Okay. Insert new line. There we are. New line. Bam. Okay. There we are. Fixed it. Okay. Let's see. The very first call with a init window should be glfw init, which optimizes the glfw library because glfw was originally designed and created to be created with an OpenGL context. We need to tell it not to create an OpenGL context with a subsequent call. glfw window hint glfw _client _API glf no _API. Because the heading resize windows takes special care that we'll look into later. Disable it for now with another window hint call. glfw resizable, glfw false. I don't know why it weirdly bothers me that this isn't just a flag like false or 0. Anyways, also knows creating the actual window. Add a glfw pointer to Windows, private class member to store reference to initialize the window with window equals glfw create window. Okay, so let's do that then. I want to make you slightly more narrow. Oh, I see. If you zoom in too much, then it teleports you. Aye, that's cool. Okay, so let's see. We're going to do frickin' I guess this is gonna be the window frickin' tab. I don't know where else it would be. So it's gonna be glfw window hint. Oh my god. And then glfw _ client _ API. Whoops. Because that's why. glfw _ no _ API. Bam. That's the wrong type. There we are. Followed by glfw window hints, and then we're doing glfw _ resizable glfw _ false. Okay. Split resizable wrong there. Could have done that faster, but whatever. Oh, is it all caps? Okay, I see. I missed the caps thing. False. Oh my god. There we are. Okay. Let's see. Now what's left is creating an actual window. Add glfw. Yeah, okay, that's right. I read that already. So now we're just gonna go here. We're gonna go window is equal to glfw create window. 800 by 600, comma space, vulkan, null pointer, null pointer. Wait, for my sandy's sake, I'm just gonna frickin' bam, 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 bam. I don't know why I'm doing it like this. Better. There, boink, boink. Oops, shoot. Cool. I like that. Let's see. The first three parameters specify the width and height and the title of the window. Rick and Morty is really funny, I swear. The fourth window parameter allows you to optionally specify a monitor to open the window on, and lastly, the last parameter is only relevant to OpenGL. Okay, it's a good idea to use constants instead of hard-coded width and height numbers because we'll be referring to these values equal times in the future. I've had the following lines above to that. Okay, yeah, so that would be numbers and stuff and things. So we'll do very quickly. We'll do should probably whatever. Actually, I could do something like pound define width. I forget. Do we need? I think it's just that, isn't it? I think that's how that works. Pound define. Whoops. Height. 600. I think I fucked that up, but fuck it, we ball. I feel like something's very wrong there, but we'll go for it, I guess. Width. Height. Okay. Expected expression. Okay. I think it's these that are wrong. Oh, Windows undeclared. Okay, that's odd. It didn't tell me to define the variable of window, I don't think. No. No, it did not. So I will trip balls and move forward. Holy shit. Okay, yeah, so window isn't being established. It's just supposed to be in window. Yeah. Alright, to keep application running until either an error occurs or the window is closed, we need to add an event loop in the main loop as follows. Let's see. Main. This feels wrong, but okay. I'm gonna comment this out because this feels wrong somehow. No, it isn't wrong. It's just fun. Okay, so we're gonna go here, and then we're gonna go frickin' void main loop. Wait, hold on. Void main loop. Why does this feel like I'm tripping absolute knuckerfucks? Hold on. Void main loop. What? Void main loop. We had an event loop in the main loop to the main loop function. There's a main loop function, right? Oh no, there is right here. Okay, never mind. I missed that. Let's see. While bang glfw window should close. Whoops. With the flag of window. Then we're gonna do. Oh, what's supposed to be two of those? Hey, look at that. Then what I want to do instead is I want to do bop. No, wait, bop. I don't know if that's correct, but whatever. Thank God it's not white space significant. Cool. While glfw poll events. Okay, so the poll events. This should be fairly self-explanatory. Loops and checks for events like pressing the X button until the window has been closed by the user. This also is the loop where we'll later call a function to render a single frame. Once the window is closed, we need to clean up the resource by destroying it and terminating glf itself. This will be our first cleanup code. Okay, so cleanup is going to be glfw destroy window of window. Yeah, I spelled window wrong because I'm allergic to windows. I'm sorry. glfw terminate. Okay. So the one thing that's bothering me now, once you're in the program, you should see a window titled Vulkan show up until the application is terminated by the window. Now with the skeleton for our Vulkan project, let's create our Vulkan object. The first Vulkan object. So Ari, if you're present, I feel like I might be missing something. It's showing here. Oh wait, no. Sorry, I'm fucking stupid. Never mind. I missed something. I misbranded. You may return to the cave. That is very valid. I am going to go hard because I'm a fucking masochist. I guess I'll put it this way: if you see a fucking Dorito in your DMs when you wake up tomorrow, everything went well enough. I mean, hey, thanks for hanging out. Sorry for keeping you up later if you want than you want to. Everything was super epic, so thanks for taking part. What might that be? Okay. Okay, shoot, what was the command to open up the GUI thing for that? Config dash GUI, and then, sorry, go on. That's epic. Cool. I will double reference it. I'll probably leave these blank, but if I encounter anything remotely odd, then I'll mirror yours, basically 1-to-1. Mm. Oh. Oh, that's neat as hell. Oh yeah. Well, thank you for the hot tip. Fingers crossed everything goes well. Yeah. Yeah, please do. Once again, thanks for hanging around. Hey, nerds, check out Ari's stuff in the description if you're around and present and existing and things and stuff. And yeah, once again, thanks again. Thanks for all the info and the gap filling, and I will catch you sometime. Oh, of course, anytime. See you around. I guess I will leave the Discord call too, because there's no point in me hanging around. Oh, I'm frozen! Yay! How long have I been frozen for? Hopefully not long. Also, yes, freeze coding hurts the brain. It tends to do that, but I mean at the exact same time, it's like, you know, it's fun. It's a learning curve. You know, it's about getting better and stuff, right? So that's what makes it fun. Let's do this. There we are. Hey, look at that. I'm no longer frozen. Yeah! Webcam isn't broken. Webcam isn't broken. Ha 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 ha. Oh, I am deep in the comment section. Oh, this is a very long comment section of hell. Okay. See, I saw the scroll bar earlier, and I was very worried that the scroll bar, like, I was gonna be like a very, very deep, long page, and I'm like, holy shit, I'm very not into it. I was like, oh, look, it's already end. Let's create the first Vulkan object C++ code. Let's go. Hoorah! Let's see, we've got 1, 2, 3, 4. Yeah, okay, this will be reasonable. This will be reasonable. Little bit of a push, but it'll be worth it. Let's see. So from here, unused variable window. Don't care about that. Use of an undeclared thingy. Maybe I have to declare this window object higher. Yeah, I think I declared it there, which was kind of silly. I think I got to do it like here. Use of an undefined thing should close. glfw window should close. Hold on. Let me go back one. glfw window should close window. glfw window should close. Should close. Oh, close window. There we are. Because if there's an error, it's probably an error with that. glfw destroy window. glfw terminate. Because of a typo there. Destroy. There we are. Huzzah! I am the master of the universe. Okay, create the first Vulcan, or create the first thingy. Let's see, is this another hell comment section? That one's pretty contained. Also at the bottom, but that's fine. They're providing a free reader, checking that fight. Let's see, creating an instance. The very first thing you need to do is initialize the Vulkan library by creating the instance. The instance is the connection between your application and the Vulkan library, and creating involves specifying some details about your application driver. Start by adding the create instance function and invoking the init Vulkan function. Okay, so in the public class, I think. Oh no, we already got the init. No wait. Huh? Oh, we're supposed to invoke it within it. I see. So it's gonna be a init Vulkan right here. I see. It's doing a create instance. Additionally, add a data member to hold the handle instance, private VK instance. Okay. Let's see. Private. VK instance. I'm pretty sure main loop is a real thing. Hold on. Yeah, you're right there. Oh, I see, because there's semicolon or colon errors or whatever. Create instance. That feels wrong. Create instance. Create instance. Create instance. Okay, I don't have a create instance. Didn't I have a create instance that I was just editing though? What? Huh? Oh no, I didn't create it yet. I just called it. I see. So we're gonna create it in just a second. Now to create an instance, we'll first have to fill the struct with some information about our application. This data is technically optional, but may provide some useful information to the driver in order to optimize our specific application. E.g., because it is it uses a well-known graphics engine with certain special behavior. This struct is called VK application info. Okay, so let's slam that in. Okay, I guess I messed up. Actually, no, let's do that. Because I want it to be just a little bit thinner so I can see it a little bit clearer. Okay. Is this... I don't know if this is in the private or public class. The last context was private, so I guess it'll be private. So yeah, I mean, let's go private, I guess. Private instance is not used. Where does this mirror to? Hold on. Oh, it's just part of the whole class. I see. Okay, so then from here, we're going to do void create instance. And then what we're going to do instead is we're going to go, hey, VK application. Holy crap. Application info. App info of whatever the heck that is. Freaking hell. There we are. VK application info. Is it lowercase VK like the other one? VK. Okay, this is... I think that's supposed to be a lowercase v. I can't tell, actually. VK application info app info. Okay, that's an error I don't like. I don't like that, but I'll roll with it for now, I guess. App info.type is equal to vk underscore structure underscore type underscore application underscore info app info dot p application name. Oh fuck, messed it up. Dot application name is gonna be equal to hello try, and then app info dot application version is equal to vk underscore make underscore version. ICS we're gonna do 1 comma 1, or I guess 1 comma 0 comma 0. Okay, I don't know. Use one undeclared item. VK structure type application info. I'm guessing there's some issue with like the VK thing. Okay, I want to check the previous one too, because is that a capital V or a lowercase v? Hold on 1 second. I'm gonna copy this, paste this. So it is a capital V. Okay, maybe it's just an issue with this, because this is incorrect. Let's just do that. Boink. VK application info. Okay, I mean, I don't really see anything else I can do there right now for that, so I mean, screw it, I guess. Let's see, app, info dot p engine, engine, name is gonna be equal to, no engine. Awesome, okay. And then from here, app info dot engine version is equal to, whoops, that's a double space, vk underscore make underscore version. Didn't I do this one already? No. Let's see, 1 comma 0 comma 0. And then let's see, app info dot API version is equal to vk underscore API underscore version underscore 1 underscore 0 underscore 1 underscore 0 comma. Okay, these are all not being imported properly. So what the heck is going on with you? VK version claim diagnostic error. Is it because the Vulkan header at the top got nuked? It seems all happy now. I mean, it said to replace it earlier. Okay, I'm gonna do this. I'm gonna do up here. I'm gonna do, this, might need to be removed, on compile. Because now everything seems happy. Okay, so now we're here. Whoops, why can't I move? Why can I not navigate? Hello? Oh, no. Boink. GG. Oh, no. Why are you doing this? What is wrong with you? Hello? Oh, because you have caps lock enabled. I'm a silly bean. Okay, so there's that. That all seems to be happy. I need to go to that loop and just reset you. Yeah, you'll help a lot. Okay, so we've done that. As mentioned before, many structures in Vulkan require you to explicitly specify the type in S-type member. This is one of the many structs with the P-next member. It can point to the extension information in the future. We're using value initialization here to use it as a null pointer. Okay. A lot of information in Vulkan is passed through structs instead of function parameters. We'll have to fill in one or more struct to provide sufficient information for creating an instance. This next struct is not optional and tells the Vulkan driver which global extensions are global extension and validation layers we want to use. Global here means that they apply to the entire program and not a specific device, which will become clear in the next few chapters. Let's see. So then Vulkan create info. Create info.s-type, vk structure type, instance create info. Create info, p application info, which points to the address of app info. The first two parameters are straightforward. The next two layers specify desired global extensions. As mentioned in the overview chapter, Vulkan is a performance agnostic API, which means that you need an extension to interface with the window system. glfw has a handy built-in function that returns the extensions it needs to, which we can pass to the struct. UN32, that, glfw count equals that, const character, I don't know what the double pointer's for, actually. glfw extensions. glfw, get required instance extension, which points to the address of glfw extension count. Create info dot enable extensions count equals glfw extensions count. Create info dot pp enabled extension names equals glfw extensions. The last two members of the struct determine the global validation layers we need to enable. We'll talk about these more in depth later or in the next chapter. So let's leave these empty for now. Create create info enabled layer count equals 0. Now we specified everything Vulkan needs to create an instance that we can finally issue with vk create instance call. Vk result equals vk create instance that points to the address of create info, pass a null pointer, and passes in a pointer to the address of instance. As you see the drawn pattern of the object, create that object creation in the Vulkan follows. Pointer is the struct to creation info. Pointer is a custom allocator. Callback's always null pointer in this tutorial. Pointer to the variable that stores the handle to the new object. Yay! Everything went well in the handle to the instance it was stored in the VK instance class manager. Nearly all VK functions return the value of VK result as either VK success or an error code. To check the instance was created successfully, we don't need to store the result. We can just check if for the success value instead. If VK create instance, address create info, null pointer, address of instance is not equal to VK success, throw standard runtime error, failed to create instance. Let's see, now we're on the program to make sure the instance is created successfully. Okay, so my issue is I don't know where it exactly wanted me to create most of this. I'm guessing directly below VK instance create info. I don't know where this would be. Because a lot of this is kind of just telling me to go for the way side, which is kind of confusing me. But I don't know what else to do. Because my knee-jerk is to set up like here, right? Or I do something like or do something like VK instance create info, and then we should do create info. Let's see, and then create info dot, I'm just going to duplicate that real quickly, is equal to vk underscore structure underscore type underscore instance underscore create underscore info. I'm guessing that's the end of the line. Yeah, Cool. Okay, and then this one here is going to be info dot application info is going to be equal to the address of app info. CREATE info, expected of that or of that. Oh, because this first one again, dot s type. Let's see, expected of that after declaration specifies. No, I don't think so. Create info. You definitely should be working. I don't know why you're not actually working. Let's see, what can I do about you? Let me do this little side thing real quickly, actually, as a little kabloofer. This is the personal thing. Let's do this one, actually. Oh, awesome. Okay. Oh, that just increases the vibes tenfold for me. Okay, so create info. That just seems wrong to me. Why? VK create info. This just seems like it's erroring somehow. Is not used. INFO. Why is this seeming so wrong to me? Oh shoot. Whoops. I honestly don't see what's wrong here. Let's do this. We'll do that. We'll do this. We'll do that. See, that updated it. That definitely updated it. I made sure it was right. I made sure it was right and it didn't work. But hey, alas, here we are. I don't know why this is unhappy. Is it perhaps because it's in a private instance instead of a public instance? Hold on. Unknown type create info. I mean, you're not type though, you're an object? Cause I'm creating the object right here. You know, screw it, let's go for it, I guess. I'm gonna move you back actually, real quickly. Oops, maybe not. No, I don't want that. Alright, let's do this. Oh, I did miss this up slightly as well. Oh no, wait, no, I didn't. I'm tripping. That's just angry for no reason. I just don't know what it wants here. I don't know why this is angry at me. VK insta create EATE info create info. That just seems so odd to me, but I guess I'll roll with it. I don't know what's going on here. Let's see. I'm gonna say possible issue. Let's see. You have to do that. We just need to pass it the structure of that. Maybe it wants it instead in create window or knit window. What was it? It was a knit window. No, create instance. Let's try that then. Maybe it's just being a little picky, you know. Let's see. Let's go like this. Maybe it just wants it down here. Oh, it's happy there. Okay, that's where it wanted. Got it. The first two parameters are straightforward. The next two layers are specifically desired with global extension. As mentioned in the overview chapter, Vulkan is a performant agnostic API. That means you'll need an extension to interface with the windowing system. JSW has a handy built-in function that returns the extensions. It needs to do that, which can pass a struct. Okay. So carrying on the same context window, I'm guessing, is so uint 32 underscore t glfw extension count equals 0. Const character points to, I did that twice, glfw extensions. I mistyped const because of course I did. Const. Then after that, glfw extensions is equal to glfw get required instance extensions, which points to not that, excuse you, which then points to glfw something. I'm guessing extensions count. Yeah. Extensions count. Extensions count. Let's see. Let's just yank that. We'll go F to the ampersand, delete the word, and then paste. Nope, I see what I did wrong. Word, yank the word. Okay, that fixed my error there. And then we're going to create info dot enable extensions count equals glfw extension count. And then we're going to create info dot pp enabled extension names equals glfw extensions enable extensions count create info. Create info is right above. Extensions. Did I actually? Oh, because I actually named the extensions up here with the T improperly. There we are. I did it also right here. So let's see. Did the extensions count? Oh my god, I did another typo. Holy crap, I'm terrible. GLW extensions. And then GLW extensions count. Enabled extensions count. That says right. PP enabled extension. Okay, that one's just a typo here. Those are very wrong for some reason. I don't know why. What the heck is going on with you? No number named that and that. Do you mean enabled? Let's see. Okay. Let's see. Do you mean enabled extension? extensions. Sorry, no member named enable extensions count. Did you mean in VK whatever? Do you mean enabled extensions count? So there's an error here. glw x 10 Sean count. You do exist it though. Diagnostic suggestions. What can I get here? I don't really know what to do about you. Visual diagnostics. I remember enabled that. Do you mean enabled? I genuinely have no idea what the thing is here, but let's just try it. Oh, is that for the library? Oh, Oh, is it just extension instead of extensions? I see. Extension names. Yay, it's all cleared. Last two members of the strict name global validation is enabled to enabled. Talk these more in depth in the next chapter, so you just leave these empty for now. Okay, so I'm just gonna do create info dot enabled layer count equals 0. Ta-da! And then we started with the Vulkan needs to create an instance. We can finally issue the VK create instance call. Okay, so VK result equals VK create instance, which then points to create info. Null pointer, and then what's the last one? Instance. Pound instance. You see the general pattern that object creation function patterns and function parameters in Vulkan as follows is pointer to a struct with creation info. Pointer to custom allocator block, so is a node pointer. This says that, in this tutorial, pointer to the variable that stores the handle to the new object. If everything went well in the handle, the instance was stored in the VK instance class member. Nearly all Vulkan functions return the value of type VK result that is either VK success or an error code. To check if the instance was created successfully, we don't need to store the result. We can just check the error success instead, which in this case is going to be if VK create instance which points to create info with a null pointer, which then addresses instance is not equal to VK success. Is not equal to VK underscore success. Then I want to let's see. I then want to throw standard runtime underscore error. Let's see. Failed to create instance. Okay, so there's the failed to create instance thing. Let's see. Let's see. Encountered VK underscore error underscore incompatible driver. If using macOS on listen local VK SDK, you might get VK underscore error as returned from gradient. According to the getting started notes, beginning with the VK underscore Cronus underscore probability and set. Extension is mandatory to get over this. First add the VK. Yeah, we're not doing all that because we're not running on macOS. Checking for extension support. If you look at the VK create instance documentation, you'll see that one of the possible error codes is VK error extension not present. Is this all for macOS? Hold on. No. Let's see. Check for extension support. Yes. Just that one of our possible error codes would be error expression not present. We can simply specify the extension we require to terminate the code. And terminate if that error code comes back. That makes sense for essential extensions like a Windows system interface, but what if we want to check for optional functionality? To retrieve a list of supported extensions before creating an instance, there's the ek enumerate instance extension properties function. It takes the pointer to a variable that is stored in a number of extensions and an array of vk extension properties to store details of the extension. It also takes the optional first parameter that allows us to filter the extensions by specific validation layers. Let's ignore that for now, or which we will ignore for now. Holy crap. To allocate an array to hold the extension details, you first need to know how many people there are. You can request this, so you can just request the number of extensions by leaving the latter parameter empty. Okay. Let's see. So this is going to be extension count equals 0. Extension I just did extension count earlier, but whatever. Okay. No, there's that. There's just deal with the view extension count right here. I don't think I need this. Now allocate the array to hold some details. Standard VK extension properties. Okay. Oh, you know what? I'm gonna do this. I'm just gonna yank you, and I'm gonna just paste that because that's long enough. I'll probably make a few typos. Boink. There we are. Let's see. Then we're gonna go to here. I can get rid of you now, actually. Then what I can do is I can go like this. I can go say, hey, VK and enumerate instance extension properties null pointer comma which then references the address of extension count, and then also want to say null pointer. Let's see. I probably spelled this wrong, so let's just fix that real quickly. Boink, and then boink, and then boink. Oh, look at that. Each VK extension properties struct contains a. Oh, hold on. I just realized there's a duplicate there. Why is there a duplicate there? I don't know. Oh wait, no. Hold on. Was that what I thought it was? Are these the exact same? No. Okay, wait. Now allocate the array and hold the extension details. Include vector. Okay, so that's going to be standard colon vector. Which is going to be VK extension properties extensions followed by extension count. Okay, got it. Extension count. Let's see. Okay, extension properties. Extension properties. See, I don't know what I'm typing wrong. I'm honestly getting pretty fucking cooked, so I'm gonna just do this real quickly. Oh no, this one's unhappy. Oopsies. There we go. Boink. Oh, you know what? I probably need to just go up here, and I probably just need to do something like pound include vector.h Is this vector? It is pound define. Actually, nah. Let's just get rid of that. Okay, so we got the vector library now. Finally, we can query the extension details, VK enumerate instance properties, VK enumerate extension properties, null pointer, extension count, and then it's extensions.data. Extensions.data. Oh, it's a function call. Whoopsies. There we are. Each VK extension's property struct contains the name and the version of the extension. We can list them with a single loop. -T is for tab indentation. Okay, so then we're just gonna do let's see. We'll do here standard cout. Which is gonna be frickin' available extensions. Which is gonna be \n. Oh, that's the wrong spell for that. Available extensions. For const auto, which points to the address of the extension, which is extensions. What I then want to do is let's see, we're gonna go standard dash double dash cout \t because it's a tab, extension, oh sorry, extension dot extension name, double dash, I'm guessing end line. I was doing \n. Yeah, I thought so. End line and \n are effectively the same as far as I'm aware. Unknown type, constant. You know, this code, the create instance function provides some details for it. As a challenge, try to create a function that checks all of the extensions returned by glw required instance. Okay, let's do this. That is a comment because I'm in no freaking mood to freaking do that right now because I'm very cooked, not gonna lie. Alright, let's see. Let's do that. And then cleaning up. The VK instance should only be destroyed right before the program exits. It can be destroyed in cleanup with the VK destroy instance thingy-majiggy. Clean up. Everybody everywhere, come and do your share. It's time for clean up. I don't know where that came from actually. VK destroy instance. Instance. Space null pointer. Let's see. VK destroy instance. GLFW destroy. Destroy window. Window. And then one more for the road. GLFW terminate. You do that. You still declared VK destroy insta. I'm guessing it's supposed to be capital V and they're tripping. I mean, VK destroy instance. What's the difference? VK. Des story. Destroy. Okay, the parameters for the VK destroy instance function are straightforward. As mentioned in the previous chapter, the allocation and deallocation of functions in Vulkan have an optional allocator callback that will ignore by passing null pointer to it. All the other Vulkan resources that we'll create in the following chapters can be cleaned up before the instance is destroyed. Before continuing with some more complex steps after instance creation, it's time to evaluate our debugging options by checking out validation layers. Yay! Okay, I'm going to try very quickly. I'm just going to see very quickly what happens if I run this, because I think I'm going to call it there. So let's see what happens, shall we? You can just make, and then vulkan test. Hey, null failed. Assertion window is not equal to null failed. Core dump, neat. I guess I'll figure that out later. Anyways, yeah, I'm cooked. This is a 5-hour stream. This is not supposed to be remotely this long, but hey, we got stuck on a side journey. So I will say thank you everybody so much for watching. Thank you so much for enjoying whatever the fuck this is. This is an absolute shit show. And hey, I'll catch y'all later. Have fun and catch y'all later. Doodly doodly, doubly doody.